Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Ladies and gentlemen, welcome back to another live stream. Alrighty, let me post the link and make sure everything is right. Copy video URL, stream. Okay, just posting the stream URL. Right, I think we're gonna wait a bit. If anyone is interested, can join us in this adventure of today. So yeah. All right, pin message, and let's go. So we're gonna wait around, I believe, maybe 5 minutes or 10 minutes, and we're gonna start the stream. So today we're going to be exploring the Vulkan API with Zig, without any libraries, no bindings, nothing. We're just gonna load Vulkan driver stuff, and we're just gonna work with it, you know, as a dynamic library. That's gonna be pretty interesting. And we got a little coffee right here to get us started. Okay, so I'm going to post up, going to enable the screen recording. All right. Alrighty, amazing. We're gonna check out on Visual Studio Code. Yeah, we're going to close the folder. So there is some libraries on Vulkan with Zig that I was exploring, like this one. Well, not a library, I think, but a binding, basically. Yes, a Vulkan binding generator for Zig. But honestly, I do not really trust the ecosystem of Zig too much. Zig is still not mature, at least not enough. I mean, especially the Zig ecosystem, and also ZLS, which is basically the syntax highlighting and editor integration for Zig. But Zig itself as a language, I do not have any problem with it. It's just that, you know, like Zig ecosystem for now is very mature and I cannot trust it pretty much. So we're gonna roll everything on our own. Okay, pretty cool. So just gonna wait a bit until 5 minutes have passed and we're gonna start pretty much. I need to make sure that the chat is visible. Let's make sure the chat is visible. Alright, pretty cool. And let's just wait a bit. First time seeing someone live coding in Zig on YouTube. Welcome Volt Flake. I do not know actually if someone have did it before. I don't know. I never actually watched the Zig live stream myself, honestly, and especially a Zig and Vulkan live stream. Well, if we're talking about Zig and Vulkan at the same time on YouTube, pretty much this is pretty much the first video on it. In fact, it's the first stream on it. So that's going to be pretty interesting. And we're not going to be using any kind of library, no bindings, nothing. We're just going to be rolling in from scratch. Of course, I'm not an expert on Zig nor on Vulkan, but we're just going to learn together on the way. So yeah, pretty much. So I think we're going to start 5 minutes. 6 minutes. I don't know. Should I wait like until the 10 minutes mark, or should we start now? What do you think? Maybe wait for more people to join in so they do not miss anything. I'm not sure, but I think this live stream will be saved for, you know, offline watching, but I'm not sure though. It may just be a live stream and then just throw it away, but who knows? We'll see. But I'm also thinking about something which is to basically live stream as to learn in front of the camera, and then basically after that I can actually go ahead and record a proper tutorial after the live stream is done. And so of course off camera, I mean not in a live stream, just a normal regular video, but yeah. I think we're gonna start. 7 minutes already, so let's go. Okay, it's gonna be interesting. Well. Let's go to documents. Let's go to the Zig folder. All right, pretty cool. So now mkdir to make a new directory, and we're gonna call this. Let's see. Vulkan Zig. I'm so bad at naming stuff, but there you go. The most basic name ever for a project. Let's go. By the way, I think I'm not going to go through graphics and extensions. I'm going to try to stick to core Vulkan functionality of the first version, just so we do not have distractions, because when you think about the window and stuff and all sorts of craziness, you know, it's very distracting, and Vulkan is hard by itself to learn. And if you add other libraries and other crazy stuff and other platform specific craziness, you just go wild, you go crazy at that point. So yeah, I think we're going to stick to compute Vulkan version 1 basically, and just try to make it as simple as possible, I think. So yeah, pretty much. And it should be hopefully self-contained. Okay, so let's actually zig init-exe, I believe. There you go, cool. Now let's launch code in this directory. Yes, I trust the authors. Okay. Alright, so this is the start of another adventure. Like, not yesterday, but yesterday, we started the Quran application in Godot engine, and today we're going to explore Vulkan with Zig. Okay, pretty cool stuff. Okay, so let's start by just removing the extra comments that there's no need of. Okay, honestly I think I have like some kind of extension to remove comments, I guess. Maybe? No, I do not. Doesn't seem like. Okay, anyways. Oh my god. This is so tedious. If I was using Vim, such a job would be much easier. Yeah, I'm not a hardcode Vim user yet, at least. So we're sticking to code. Okay. Unit tests, run step, run cmd, and b.install artificate. And I honestly do not know why programmers like to name their variables first like one character. I never understood that, I guess. Anyways, function parameter, shadows, declaration of build. VS Code can do all Vim stuff with proper binding extensions. Well, that's true. I'm just not a hardcode user, I guess, of editors. Okay, well, I don't know where there is a shadow declaration of build here. Oh yeah, because it's the function called build. Well. Anyways, never mind. Let's just go ahead and go to other stuff now. We do not need any of this, okay? And we do not need any of this. And let's try to run this stuff. Okay. So zig build run. There you go. All good. So let's start our adventure. So the first thing would be is to translate the Vulkan header from C to zig. And this is what we're going to do. I mean, we could actually go ahead and say and use C import and stuff, which would be very fast. But unfortunately, that doesn't give us like code highlighting, like auto completion, etc. So I found another, like another way of doing this, which is to basically say new file, and here we're gonna call this, I guess, cimports.h, and then I can include whatever headers I want of C. For example, here include vulkan.h. Of course, you need this in you need to somehow, like, for example, in Linux, I had to install some packages to get the Vulkan stuff, the Vulkan loader, etc. So yeah, you gotta look up in the internet how you could basically set up Vulkan. I'm not gonna cover that in this video or in this live stream. So okay, so this is the Vulkan header. Cool. Now I'm going to go ahead and basically translate that. So zig translate -c, I believe, if I remember well, -cc or -c, not sure. Anyways, and we're gonna say cimports.h, and I believe we need -lc, if I remember. Yeah, there you go. And it actually gives you the translation on std out, basically on standard out, basically just prints it to you. So what we're going to do, we're going to redirect that into a file. In this case, we're going to redirect it to a file called src/ let's say vulkan.zig. All right, and suddenly we're going to have a vulkan.zig. Cool stuff. So this is the translated file from a C header to, well, a zig header. Okay, pretty cool. So I'm gonna put this into a script. So yeah, okay, new file. Here I'm gonna call this translate cimports.sh, or we could just leave it without any extension, and then we could basically say shebang and /bin/sh, and then we could basically paste in the command. So now I could say chmod +x to give execution permission to that file, translate cimports. And there you go. Now it's executable. Now every time I want to actually translate the this C imports file thing. And honestly, I'm just gonna call it c.zig, you know, fine, who cares? Maybe, yeah, C, I'm just gonna call it C, honestly. So let's remove that Vulkan.zig. Okay. Hopefully I didn't remove anything by accident there. Anyways, c.zig. Now I could basically go ahead and say translate / translate C imports. And there you go. Oh, I actually removed it in the wrong place. There you go. So now we have c.zig, which would contain all the C imports. We could basically do any kind of C code here and it would do the trick. Okay, fine. Now let's actually import that. So const C is equal to import c.zig. And now suddenly we're gonna have all the cool stuff, as you can see here. And we also have auto-completion, which you wouldn't have if you used you know, C import thing, unfortunately. And I hope that it would improve in the future and get fixed. But yeah. Okay, pretty cool. Now, I think you could already use Vulkan without any problem by just going ahead into the build.zig file and basically say ex, I believe, .link C libc, right? First of all, and second of all, you have to link the system library, and the name is Vulkan of the system library. Of course, you should have this as a system library, Vulkan as a system library. Okay, so it should be installed on your system for this to work. But I'm not going to go with this way. So I mean, if you use this way now, congratulations. You can just basically say c.vk create instance and you could just roll on with your day. It's just gonna work. Does translate-c always work correctly? Honestly, I'm also doubtful of that. I do not think it would work with all sorts of cases. There's probably some bugs because it's such a thing that is not so realistic. I mean, I cannot even understand how it works. I mean, it's just like a miracle of some sort. So I do not think it will always work, but especially for such you know, basic files like header files, etc., I do not think it would fail. But at least until now, I used it. And in fact, C import, you know, that C import thing, when you do it, you know, this basically does the same exact thing. It would basically run zig translate-c on that thing, and it would just basically automatically do that for you. But it's essentially the same exact thing. But yeah, now the problem with this kind of setup is the fact that this is not the best way to use Vulkan stuff, okay? Why? Well, if you look into this page, which I'm going to link to it, you're going to find a lot of information about the application interface to the Vulkan loader, which I've read just, you know, a couple of days earlier, I think, or maybe just yesterday. Honestly, I do not remember, but anyways. So I really recommend reading this if you're going to start with Vulkan stuff. It's pretty interesting. But basically, the gist of it, I'm not going to read through all of this, but the gist of it is that here's your application. Here's our application. And then when you call, like, let's say a Vulkan function, it have to go through a loader. Now the library that we linked here, where is it? In build.zig, okay? So when we said link system library, that Vulkan dynamic library is actually a loader. It's not Vulkan itself. Vulkan itself is just an API to the drivers, to graphics drivers, okay? So you're basically linking the loader, and every time you call a function, you have to go through that loader, and then you have to go through all the layers you activated for your application, if there is any, and then you go through some loader terminator, and that loader terminator redirects your call to one of the drivers, depend on which physical device you're using. So for example, basically why this is all the case, Basically because, well, of course, there is something called layers in Vulkan, which could intercept function calls, and it could do all sorts of stuff, cool stuff, like, for example, validation layer. It could dump the API calls that you're doing. I'm going to show you in a bit what's this all about, but for now, any layer will be in this kind of chain right here. Anyways, and the thing is, you could have like Intel GPU and NVIDIA GPU, and each GPU have its own driver. So what happens is that you need somehow to call the correct driver. So when you're actually working with the driver, you have to go through all this chain, and then basically the loader should basically kind of try to redirect you to the correct driver that you're working with. Okay. Now, when you use something called vk get instance proc address to get the addresses or the function pointers of the instance, this becomes this, okay? So you have application, loader, trampoline, layer A, layer B, layer C. Yeah. And basically, I think the loader terminator, I do not think that's the case though. Hold on a second. I think instance function needs, actually this is the instance functions, right? And then basically when you're working with vk get instance, well, I'll say I do not actually, hold on a second. Does using the loader export functions? It's kind of crazy, but anyways. So the gist of it basically is that the loader terminator will no longer be there, and you will be just from layer C, you will go directly to the driver. All right, interesting. But then when you use, I think, vk get device proc address to get your function pointers, you'll get function pointers directly to the driver. So you no longer have to go through the loader. So you basically go application. There's no loader trampoline. You just basically go ahead, right ahead to layer A, layer B, layer C, and then you go directly to the driver. If you didn't activate any layers, that means the application will call directly to the driver, because you're using vk get device proc address to get the function pointer to the driver directly. But yeah. So that's basically it. Now, to be able to do this, what we gotta do, we gotta actually load the Vulkan module ourselves. So I'm going to remove this guy. I'm going to only keep link libc. And honestly, I do not know why I need to keep link libc, but I mean, since I'm not linking anymore statically kind of to the Vulkan module, or should I say shared library, but anyway, it just doesn't work if you don't keep it. Anyway, so we're gonna use something called dlib. So inside of std, there is dynlib, dynamic library basically. Okay, so we're gonna use that to open up a path. Now this path changes from a platform to a platform, okay? And how we can know this, I found something called Vulk library, which I used actually to interface with Vulkan when I was working with C, the C language. But basically, this library on GitHub, hold on a second, Vulk GitHub. There you go, meta loader for Vulkan API. Now, if you're working with C, in fact, even if you're working with Zig, you could probably use this library too, but I'm not going to do that. So you basically say Vulk initialized, Vulk load instance, etc., and it would just basically take, do all that loading stuff for you. But now what I wanted to show you is that it's actually opening the dynamic library. It's using DL open. There you go. This is the function that is basically equivalent to std dynlib open in Zig. And as you can see here, if defined Windows 32, Win32 basically, then it loads the library is called Vulkan-1.dll. If it's called Apple, if it's in the platform of Apple, it's gonna look for libvulkan.dlib. If not, it's going to look for this one. Otherwise, it will look for molten vk. Otherwise, if it's not Apple or Windows Win32, then it's gonna look for libvulkan.so.1. And so this is basically exactly what we're going to do. Okay. So first of all, I'm going to create some struct called, I guess, entry. Entry like this is equal to a struct. And of course, as always, const self is equal to this. There you go. Now what we're going to do, we're going to have an init function and a dinit function. Of course, dinit, as always in Zig, should be by convention return void. Deinitializer should never fail in Zig as a convention. But yeah, the init function would return an error or self. Okay, now this is library const library is equal to that, and we're going to open what? Well, here we're going to say get library name, and I'm going to create another function down here, fn get library name. Okay, and also I'm going to have a const library names is equal to switch. Switch what? Well, we're going to switch on std, I believe, dot I think built in, no, or .os. I honestly do not remember, but let's see. Zig std.os switch, maybe. I do not remember exactly how they do it, but I think it's built in dot os. Yeah, the os dot tag. Let's go. Switch built in the os dot tag. os dot tag. Now, of course, we need to load in built-in. So const built-in is equal to import built-in. Sadly, we do not get syntax highlighting for built-in for some reason. I mean, if you say this, as you can see, it doesn't give us that. But anyway, we're going to switch on this guy. And here we're going to switch on that, and if it's .windows, I believe, then we're going to do what? Well, where is it? There you go. Okay, we're going to use this name. Okay. If it's, I do remember there was a snippet for this built-in the os.tag, which was nice. Hold on a second. GitHub Zig. Okay, there. This is good. So I'm going to use this guy, the iOS, macOS, tvOS, and watchOS. I think there would probably be other stuff, but anyways, he said that there's std.built-in. Are you sure that it works with that? Because last time I checked, I think it didn't actually. Oh, actually it does work. Crazy stuff. Okay, cool. It seems to at least highlight it, but I'm not sure. But yeah, we can try it. cd.builtin.os.tag. Now watchOS here. This is basically Apple, I believe. Although I'd like if I can find the documentation of all the platforms for this guy. Built-in .os.tag. Maybe I should look for built-in in GitHub. GitHub zig built-in .zig. Something like that, maybe. And then hopefully I could look for os.tag and hope for that I could find it there. Sadly, I do not see it. There's also another platform called AIX. I'm not sure what's that. It seems like there's also freestanding. WASI, UFI, I guess. That's crazy stuff. CUDA. But anyways, we're just going to stay with this for now. But the problem that we're going to find here is the fact that, let's, for example, in Apple here, there is 3 possible names, okay? So if this fails, we have to try this. If this fails, we have to try this. Same thing with Linux. So instead of using one name, we should probably use some kind of array, basically. Okay, how to do that? Well, I believe, if I remember well, how I did it is, I guess like this, and then like this, maybe? I always forget about how to do this. Const u8, and I believe maybe there should be something like this. Hopefully I did it right, not sure. Seems all good. I mean, at least it didn't complain yet. So yeah. Now here we're going to basically get this guy. We're going to get this guy. By the way, this Vulkan library is pretty wildly used for Vulkan when it comes to C and C++. That's just an information to keep there. So yeah. Shouldn't it be for multi-dimensional array? I mean, why do we need the multi-dimensional array? This is not a multi-dimensional array. We're basically switching on the OS, and since this is a constant, it will switch at compile time. It will see if we're compiling for Windows. If we're compiling to Windows, this library names will resolve to an address to this constant array of names or strings. And same thing, if it find any of this kind of like platforms that we're compiling into, is gonna go with this array, you know. So that's basically how it goes, I think. Although I may be wrong. So yeah. Else, so if there is any other platform, we're gonna basically for now use this guy and use this guy. Okay, cool. No need for this, okay. Now that's interesting. So we have basically a constant library names that will basically get resolved at compile time automatically to any of these arrays of strings at compile time, depending on the platform. Okay, now here in get library name, I think, well, not that actually. Hold on, let's just do it here anyways. So we're going to go through all the library names. So for library names, and then we're basically going to capture the library name. Const library. And here we're going to try to open that library. Now we're basically going to get either the library opened or we're going to get an error. Now if it's an error, we should basically look for the next one. Otherwise, we should basically break. We have found the library. So if library, then I think we're going to basically return it, I guess. Return library, I think. Otherwise, if we don't find it, we're just going to return error not found, I think. So I'm going to put this into its own function, I guess. fn Lloyd library, which basically would give cd.dynlib or an error. Okay, pretty cool. Now, of course, here we're going to get that on. So library is equal to Lloyd library. And we're basically going to say try to Lloyd the library. And yeah. And use local constant. And now we're basically going to have a member variable in this struct, which is going to be called, I guess, well, let's call it handle. Anyway, handle is going to be a cd.dynlib. Hopefully I'm spelling it right, but yeah. Okay, here we're going to return this, and we're going to say that handle is equal to the library. Oh yeah, I need a point here, a dot here. Okay, pretty cool. I think hopefully that should work. Now we just should create an entry here, is equal to entry dot init, and I should try to do that, and basically after that I should basically defer entry dot dinit. And of course in the dinit function we're basically going to get the self, I believe. I'm gonna say self.handle, well, dot close, I guess. Not sure if I need a reference here. I guess I do, but I'm not sure. Anyway, let's just see what's gonna happen here now. Entry, defer entry dot dinit. Okay, let's see if this works by any chance. Sig build run. Okay, we have an error. Root structure file built in has no member named OS. Alright, so I think built-in of std doesn't have what we need, maybe. Let's try this up again. Const built-in import built-in. Let's try this up. Okay. Expected type bool found this craziness. What? Well, I think what I'm going to do is basically I'm just going to do this. I do not need this. If that, then return. We're going to, of course, capture the library here. Otherwise, if there's an error, we're basically just ignoring it, I think. So expected optional type found. Okay, so I think we do need maybe the else statement. Else, and you basically capture the error. Although I'm just going to ignore the error in this case. Of course, return library here. cast discards const qualifier, or use catch. Are you sure? Catch. Because basically I do not want to do anything. Well, maybe. Actually, hold on a second. If we... What? Okay, if I say this, hold on. So, return. Not return though, hold on. But the thing is, I need to return, you know. I do not think you could do that with the... hold on. I do not think that would work. I mean, return catch continue. I wonder if that would work. That's crazy. Catch continue. Let's try. Okay, I have an error in. So this shouldn't be a constant, seems like. So let's make it a variable. And where we have a problem again. Maybe this should be a variable. Huh? That's crazy. If I do this though. Okay, that seems to work, I guess. Hopefully. Well, at least it compiles. So if I say const here, would it work? Seems so. If I say const here, no, it doesn't work that way. Okay, so just var here. All right, so pretty much, hopefully this is it. We pretty much loaded the library. And yeah. Now we gotta look up something called vk get instance proc address, or ADDR. So how are we going to do that? Well, entry.library. Oh well. Can I maybe have like a function here called, I guess, hold on a second. Lookup maybe? Okay. And then void. And I believe you would give it like a name or something. But basically, you would get self. And then you would say self.handle.lookup. And here you should pass in. Unfortunately, it doesn't give me autocomplete here for some reason. It's just so weird. But anyway, I guess we could just go ahead and look for std.lib, and let's look for lookup here. So comp time, you give it a type, which is basically a type of the function pointer that you want, and then you give it the name. Okay, cool. So lookup. So the type is basically c.pfn, which is basically the pointer, the function pointer type. pfn vk get proc address, get instance proc address. So we're pretty much going to use the loader library, the library that we loaded, to do one thing, to load this vk get instance proc ADDR function pointer. And of course we do need to tell it the name, which is vk get instance proc ADDR. Now c.pfn const vk instance. Well, honestly, I would like to do it here in the init function, really. So lookup self handle, and we're gonna have get instance proc addr. Hello, Travis Staylock. Hopefully I spelled your name right. Welcome to the stream. C.pfn vk get instance proc address or addr. Okay, cool. Oh my god, my coffee got cold. Okay. Okay. So I think here we do need maybe just... Honestly, I'm just going to do this directly, really. Let's just do it here. So dot get instance proc addr, and we're going to use this guy, I guess. Well, we're gonna use basically the library. Oops, what I'm doing here. Equal. I seem to recognize some things here from Discord. Zig help. Oh yeah, I've been looking for some help on things in the Zig community. If you go to Zig help, I've been actually looking for some questions, some answers to some questions. I do not actually remember them, but I think Dynlib. Yeah, file not found in Lloyd and Dynamic. So I did ask a lot of questions. File not found in Lloyd and Dynamic library. Okay, there you go. But I couldn't find an answer, for example, for this, for example. So, but anyways, what's the other question? I do not actually remember those questions. Hold on. Is there a way to actually get all your answers, all your questions? Doesn't seem like, I guess. No, doesn't seem like. Anyways. They were listed here, but somehow they just have gone. Anyway, couldn't remember them. Okay, so if we zig build run, I think right now, Discord search is meh. Yeah, it is. So if we say zig build run, what's gonna happen here? Access of union field pointer while field optional is active. So when I first get into this error, it took me a while to figure out a solution. And in fact, here you go. I actually asked this question because of that, which is to basically remove optional. Yeah, there you go. So remove optional from a type. So I asked how to remove the optional from a type. For example, turning the type U32 to U32 optional to U32. And I got a lot of questions first from Quantum Developer, and I also got from Travis. And using the normal Discord search in Zig help from username. Cool. Jeremiah, welcome to the stream. So how is it goes? I think in Zig help. No. Maybe from Codotaku. Oh, the search bar above it. Okay. In Zig dash help. From from Codotaku. Okay, let me see all my questions. Okay. All right, so this is I think the latest one. Yeah, new. Destructor corresponds. No, this is just a response. Okay. Here is the latest one, which is get size allocated memory using row alloc. So this also have to do with this, and unfortunately I couldn't find some great answers yet, at least not a solution yet. So get type from string name, this one too, and I'm probably going to use a solution we got here, which is this guy right here. Okay, but yeah, we'll keep it for its time. Get type from string name. So there was a lot of cool stuff. Okay, there was a lot of cool stuff that we're going to check out later on. For now, let's just go step by step, I think. But basically, we have this pfn vkget instance proc addr, and unfortunately, they're all optional because in C, all pointers are optional. But in terms of you know, of a function pointer, like it shouldn't be optional, I guess. So what we should do here to remove the optional, instead of declaring that without the optional, what we could do, we could use, there's two solutions. In fact, at least I think there's a lot of solutions though, but one of them, or two of them that we found in, where is it? Using row alloc. Let's actually look for the other search. It's kind of crazy here. Use if opt value to, no, we cannot use that because we're not trying to remove the optional from a value. We're trying to remove the optional from a type. Okay, so yeah, which of course you cannot do in other languages, at least most other languages, because you do not have comp time. Although you can do it using, for example, templates in C++. I think you can probably, but yeah, the templates are horrible in C++, at least for my opinion. Right. Anyways, how to remove optional? Okay, so there's two solutions that we found. So from Quantum Developer, you could basically say type info t, and you should make sure that it's optional, just some added safety check so it works even if you throw a non-optional function in there. And you would return type info of that type t, which is of course comp time. It's going to be a type. And you say .optional.child, and somehow that removes the optional from it. And there's another solution, which I guess I liked more because basically it's part of the standard library. So instead of doing it manually, we could just use this function called std.meta.child. So I think we're going to use this one. And how you would do it, basically here. So instead of saying c.pfn vkget instance proc address, we could say std.meta.child, and you could give the type, which is this one, and it would remove the optional from it. And we're done. But of course, I should also remove it from the other place, from the type itself here. Okay, so this is it. Now if we try to build this, okay, expected type dynamic library found constant. Okay, so this should be var, I believe. Zig build run, and there you go. I think it works, which is nice. All right, cool. If there's any suggestions to make this better, I'm very new to Zig and Vulkan. So yeah. Okay, pretty cool. So now I think we got the entry. The next thing would be to use that get instance proc addr Let's try to do that. Entry.getInstance proc addr. And if we look into this pfn, it takes a vacay instance, and this is basically just any opaque pointer, and it would get a C string. So yeah, and it would give you a pfn vacay void function. So how we could use that? Well, since we are trying to get the function that actually creates instances in Vulkan, we do not have an instance yet, so we pass in null here, and then here we tell it which function we want, which is in this case vacay create instance. Now this would give us kind of like a vacay void function, basically kind of like a what can I say, a generic function pointer type kind of thing. So you should cast it to that type exactly. So how you do that? Well, const create instance is equal to that guy, but of course we should ptr cast, and we should give it this value, and the type would be, in this case, would be c.pfn vacay create instance. Okay, there you go. Hopefully this is right. Maybe I do need that child thing again, possibly. So get instance proc addr. Well, let's just try this, I guess. Sig build run, let's see what's gonna happen. Well, it seems to be fine somehow. I don't know why that's the case. But let's try to use this function now, I guess. So create instance. And to create an instance, you need to get, well, you need vacay instance create info, a reference to or a pointer to it, and then vacay allocation callbacks, and the reference to where you want to put that vacay instance. So let's do that. Okay, so first of all, you need the info, the create info. But anyway, I'm just going to call it info for now. And we're going to say c dot vacay instance create info. Okay. And here we should pass some stuff. Now we should go, of course, to the documentation of Vulkan here. And there you go. This is the specification for all the stuff you need to learn how Vulkan API works. So first of all, we need an S type, which basically exists on all Vulkan structs. You need a pnext, which also the same thing as S type. And vacay instance create flags, application info. This is a reference to another struct, which, by the way, we could keep as null. For flags, we're just going to keep as 0, and pnext we're going to keep as null. Sorry. And for structure type, we're going to go with vacay structure type instance create info, I think. And p application info, I'm just going to go with null because you can. I mean, look at this. The p application info is null or a pointer to a vacay application info structure. If not null, this information helps implementations recognize behavior inherent to classes of applications. Vacay application info is defined in detail below. Okay, so vacay application info you could use, for example, to specify that you want to use another version of Vulkan. But since I'm just going to be using the first version, I do not need this at all. In fact, there's also, of course, other kind of fields here. There's, for example, you could give it the application name, the application version, the engine name, the engine version, and here the one that I talked about, which is the API version. Now, honestly, I do not care about any of these. API version, I do not care about it because I'm just going to be going with the Vulkan version 1. Engine version and this stuff is not really relevant to me, at least for now. This is probably being used for example, the drivers could basically optimize some things for certain applications or games, like for example NVIDIA game ready driver. I know they, for example, do some updates to optimize some sort of game. Maybe they're using the application name and application version, etc., that you pass into Wiki application info to do that, so they can identify that application, etc. But anyway, at least for me, it's never really made sense to give anything other than null in this case. But anyway, so there's a lot of crazy cool stuff, and there's also enabled layer count. I'm not going to enable any layer, and no layer names at all. I do not need them, and I'm going to tell you why in a second, because there is a much better option, a much better way of doing it. Enable extension count and enable extension names. You would need this if you want to enable some extensions. For example, if you're going to work with the swap chain, you would need to enable the swap chain extension. But for now, I'm going to focus on Vulkan itself. No windowing, nothing like that. So we do not need that. We do not need swap chains and stuff. I'm just going to focus on the core Vulkan API. So basically that means I'm going to focus on Vulkan compute, basically, and the basics, the essentials of Vulkan, instead of going crazy about the other stuff. Okay. Cool. All right. So Wiki instance create info. We're going to start with well, let me actually go to it, and I'm just going to copy this, and I'm going to put it here. I'm going to comment this out. I'm going to say .s type is equal to c .vk structure type instance create info .pnext. I never used anything other than null for pnext, at least for now as a beginner. But anyways, .flags is equal 0. .p application info. I'm going to go with null for now, for my case. Enable layer count, I would always go with 0, because there is a much better way of enabling layers that I'm going to show you in a second. But yeah, pp enabled layer names. So by the way, this P means a pointer. PP means a pointer to a pointer, basically a double pointer. Because in PP enable layer names, this is going to be a list of strings. That's why it's a pointer to another pointer. But yeah, this one will basically it's a pointer, right? So here I'm just gonna say null. And the other one is which one it is next? Enable extension count. Okay, it's equal to 0. As I said, this would be useful, for example, if you want to enable the swap chain stuff, etc. If you want to create a window. For me, I'm not going to do that, to keep things simple for now. Later on, it may actually extend this to that, but for now, this is fine. Okay. And use local constant info. Okay, cool. So we're done with that. Now we could basically pass it into info. And the next thing would be the allocation callbacks, which I'm just going to go with null. Or honestly, since I'm going to possibly use that allocation callbacks for debugging, let's just create a variable for it. Const allocation callbacks. It could be used, for example, this could be used basically to customize to create your own Vulkan allocator, which would be useful, especially for debugging. Although if you're not so good at creating allocators and you know exactly what you're doing and why you're doing it, then basically just leave it as null. Why? Because when you leave it as null, that means you're giving the driver the ability to do its own, to basically implement the allocator, So you're just going to use its own allocator, which would probably be so much optimized than you could ever do. But anyways, you got the point. But this is basically mainly used for debugging purposes. For example, you could track how much memory is being consumed by Vulkan driver currently or something like that. Anyways, the allocation callbacks, there you go. And the other thing would be a const instance, and finally you would get your instance into a variable. So c.vacate instance, which is going to be undefined, and you're going to pass in a reference to that, so we could put the instance right around the corner, right around there. Okay, and hopefully that would work. A nice shortcut here, maybe var info equal std.mim.0 init c.vacate.stype. Oh, that's interesting. Or const info is fine too. Oh, let me see. I mean, I understood what you're trying to do here, but let me see if it works for me. 0 init. So you give it a comp time and any type, which would probably be okay. Since all the other fields are essentially 0 or null. Right, yeah, that's true. So you would say c.vacate instance create info. Oopsies. Init. Here you would give it a struct. Yeah, struct. And I believe you would basically give it this guy, right? Because all of that stuff is null or 0. Well, that makes sense. Now I could basically remove this. And yeah, that's amazing. That's pretty nice. So I've been actually using something similar in C. It's called, I do not actually remember what it's called, but let me show you. So GitHub, let me go to my GitHub. Hold on. Because I've done a Vulkan tutorial before using C, the C language. So if you go to Codotaku Vulkan tutorial, at least I got a triangle working there. So yeah, src and whatever. I think let's go with maybe context, for example. Okay. Let's see. So you'd basically do this, for example, and then you would define anything you want, other than anything that is null or 0, basically, which I've done here. But anyways, so hopefully this would work. If I zig build run now, okay, what we got here. So I should remove the optional from the create instance, because I think basically so maybe I should use std.meta.child here. I should use that maybe. Let's try it out. Oh, it shouldn't be const here, it should be var, because we're going to be changing it. Value of type cint ignored. Well, create instance actually gives you back a result. So we're going to switch on that result. Now, if it gives us a c.vacate success, which is essentially 0, that means, well, success. Otherwise, you have a problem. But for now, let's just do this, I believe. And I think this is the time to basically put this into a function, maybe. Create instance. I think this const create instance thing, maybe we could do it on the entry. Hold on, 0 init info. Yeah, I think so. So let's put it there, I think. Fn this is kind of like basically private methods. So fn create, well, not fn create instance. Actually, I'm going to basically say create instance here, which is going to be std.meta.child c.pfn vk create instance. Let's go. Other than that, we're going to, let's see, well, dot create instance is equal to that guy, ptr cast, and it would need let's see, entry get instance proc addr. Well, do this maybe. So here we're going to say we're just going to use get instance proc at addr directly, and here we should actually do it like this. Here I'm going to say const get instance proc addr. Okay, pretty cool. And also, just to keep it pretty maintainable and stuff, you know, let's just do this. Create instance const. Okay. Cool. Now, hopefully, what we could do. I believe. In this case, we could basically say entry.create instance. I think 0 init. Okay, let's see if this works. Switch must handle all possibilities. For now, just say else in defined. Okay, looking great. Now I think I'm going to put this create instance thing into its own kind of struct. So we're going to say const instance is equal to struct. Else enreachable may be better. Well, that's true. Else enreachable. Does it work like that? How do you do it? It doesn't seem like it works like that. It doesn't seem like it works like that. You have to do it like this. Oh yeah. Well, what? Oh, and defined. Well, I wanted to actually say enreachable. I do not know why it. I actually wanted to use enreachable, right? But somehow I said undefined. Anyway. Well, not necessarily that the compiler have actually think that is correct, because I didn't run the compiler. ZLS is honestly very weak. I'm not so satisfied about ZLS. So far, I very much love Zig so far, but you know, the ecosystem around it, not so much, honestly. But I understand, you know, it's like still a very young language, so there is still a lot to go. But yeah, anyways. So yeah, anyway, struct. Now here we're gonna have again, well, of course, first of all, as always, const self is equal to this. And then next up, we're gonna have init, which is going to give an error or self, I believe, and dinit, of course, void. Okay, cool. Now let's probably get all of these crazy things here, and here we going to need an entry. Now I'm not sure if I can get away without the pointer here. I honestly not. I mean, I understand very well what's the difference between a pointer and not a pointer, etc. But Zig is kind of it's still ambiguous for me how Zig does its stuff when it comes to function parameters and pointers, you know. But anyway, so yeah, init, dinit. We need here the entry, which kind of like the entry is basically kind of like the Vulkan library, basically. But yeah. Now next up, we could, of course, also dinit. Now in the sense of dinit, we have to actually say vacate destroy instance, which means we also have to load vacate destroy instance. But we have to load vacate destroy instance for that particular created instance. So basically, after a successful creation of instance, we should try to load its destruction function pointer. So here in vacate success, if it's success, make a helper function to get rid of optional type. That's true. But let's first of all just get rid of, like, finish this up, I think. So c.vacate success. Okay, what we should do here now. Let's see. First of all, at the end of it, we have to return instance, the instance that we got. Actually, no, we're gonna return an instance struct. Okay. So how we're going to do it? We're gonna do this, and then basically we're gonna have a handle variable or field, which is gonna be c.vacate instance. Okay. And we're gonna return handle is equal to instance. Why I'm calling it handle? So instead of having calling it instance and then the struct itself is called instance, and you would call the variable instance, so you have to say instance.instance, which doesn't make a lot of sense. So I'd rather, you know, call it handle, just to avoid such a crazy thing. Anyway, like many things in Zig, I like to use const variables and by-value params, then change if the compiler complains. Yep, exactly. So I think we're just gonna go with entry like this until the compiler complains. I mean, I found myself also using the same strategy, pretty much, and it works so far, honestly. I never really had a problem with that. So yeah, here we need dot. And what's next? So here we also need another function called destroy instance, which is going to be an std.meta.child, and we're going to have c.pfn vacate destroy instance. Okay, cool. Now I could have actually loaded that destroy instance here too in the entry, but the thing is, if you notice here, when we wanted to fetch the create instance function pointer, we didn't have the instance at that point, so we had to pass a null here. But in this case, we have the instance, okay, which would be fine if you do it here. But it's better in terms of rules to do it for each and every instance. So yeah, at least I think so. Okay, fine. Now dot handle and then dot destroy instance is equal destroy instance. I hope that Zig maybe adds something like Rust, where you basically, if the variable is the same as the field, you would basically just say destroy instance and you would just do the job. But yeah, const destroy instance is equal to, and here we're gonna do the same job again, just kind of similar to this guy, although this time it would be pfn vacate destroy instance here. And also get instance proc addr. Here we're going to have instead of null, we're gonna pass in the created instance. Use of undeclared identifier. Okay, so we have to get that from the entry. And that's basically it, I think. So const destroy instance, return, handle, destroy instance, etc. I wanted that too. There have been proposals. Yeah, that would be pretty cool. Anyway, so in the init, we have to call destroy instance, but I'm doubtful it will happen. Yeah, it seems like to me that the author is very the creator of the Zig language seems very opinionated about his solutions. Honestly, I do like that for a lot of things he's done. But yeah, anyway, the inits. But hopefully such features would be added. But yeah, I understand that he's trying to keep the language simple. And I honestly very like that. I very much like that kind of thing, that principle. Because my first expert kind of language was Lua, which you could basically learn in a week or so. But the meta tables, there is a concept called the meta table and a table, which is very extensible. Just like Zig structs, basically. You can do anything with it, you know. You could make OOP, you could create basically anything you want with that system and any data structure just using that. But yeah, I think Zig is pretty much going in a similar direction. But yeah, anyway. So here we're going to say self.destroy instance, and we're going to give it the instance. Self.instance. Okay, now next up what we do, we'd basically say const instance is equal to instance.init. We give it the entry, and then we say defer instance.the-init. Zig build run. I think maybe we need a pointer here. No, it doesn't seem like. Oh, I need a try. I need to get rid of the error. Zig build run. Expected 2 arguments, found 1. Oh yeah, I think we need the allocator, the allocation callbacks, right. Okay, so from where we're going to get that? Okay, so we have to store the allocation callbacks. Because the thing is, the allocation callbacks instance that you use for the creation of an object, of a Vulkan object, it should be the exact same for the destruction of an object. So we should enforce that in our API. So here I'm going to say allocation callbacks. Although I may actually abstract that allocation callbacks into its own struct, maybe. I don't know, but yeah. Let me know if you think that would be nice. That would be good. But anyway, so here we gotta say c.vk allocation callbacks. Okay, cool. Now, of course, this would be a reference, and here we no longer need this. And then we should also store it, of course. Nice. Now we could basically say comma self.allocation callbacks, and hopefully that would work out. And of course instance.init entry, and here after that we're just gonna say null. Zig build run. Misinstructs field allocation callbacks. Well, that's true. The allocation callbacks is equal to allocation callbacks. Okay, Zig build run. c.struct allocation. Oh yeah, it should be able to be null. And in fact, we could even say equal to null, but there's no need anyway. Zig build run, I think. Now expected type c.struct vk allocation callbacks. Found type of nil. Where is that the case? Oh yeah, I think we should also add it here. No field named instance in struct main instance. Oh yeah, sorry, dot handle. And seems we got a segmentation fault. That's scary. I wonder why that's the case. Allocation callbacks. Weird. By the way, let me use vkconfig. And I told you before that I'm not going to activate any layer at all because I do not have to. Now, you would need that if you want to basically debug, for example. There is a validation layer. How are you initting the allocation callbacks? Well, I'm just passing null. If you pass null, that means Vulkan will basically use, the driver will use its own kind of allocator. Are we linking libc? Because if not, that would happen. Well, we're doing that. Anyways, vkconfig. So if you run this vkconfig, you would automatically get validation layer if you activate it here. So you do not have to actually embed it into your own application, which is very nice. Probably because of ignoring optionals. Oh. Where exactly? Clear. So we could do something. Oh, hold on a second. What? Create instance status message. Object 0 handle type. What? Can I see the hold on, the API dump? This will tell me the Vulkan API functions that got called. So if we do that now, we could basically say clear and then sig build run, and as you can see, it would tell me all the functions that happened. So as you can see, vk create instance have been called, and it actually gave vk success. The allocator is null. Vk instance. Structure type is correct. So what's wrong there? Oh, vk destroy instance, I think. Yeah, oh my god. The wrong name. Yep. The wrong name. Alright, that's why we should abstract this into its own function. Okay. Sig build run, and it works. As you can see, it's calling vk create instance, return vk success, and then it's calling vk destroy instance. Done. We have just created a Vulkan instance. And you can think about a Vulkan instance just like, you know, kind of like your application entry or handle towards the driver kind of thing. But anyway, some helpful functions are must have. Yeah. So let's see what we could do about that. So we have actually, thanks to the Zig community, we have found a cool function that we can use. Or should I say we have created a function that we could use, but it's called Again, I do not remember. Oh my god. What was it? I think type name, something, I said something about type name. No. I'm going to use that kind of trick from, well, first of all, in channel, in Zig help. There you go, in Zig help. From Codotaku. Why it doesn't want to do that? There you go. There you get tag from string name. There you go. That was crazy. Okay. There you go. I think it's this one. So there's this one and this one. I didn't actually see this one. What's that? I think this is a more generic function, I guess. But for now, let's just go with this one, I think. Okay, let's actually get this one in. And let's see where I would put that. Well, let's see. Pub fn call. Why get the type from string name if we can get string from type? I mean, I don't know. So, I mean, if there is a better option or better way, let me know. So, PFNs. Well, in our case, PFNs in this case is C. It's the struct that contains the function pointers, or should I say the file? But anyway. And here we have the library, which is basically a handle to the entry. So, so handle, self.handle. Okay, so I think we should put this probably somewhere around here. And then here we could basically have self. And hopefully we'll do the trick. Although I think maybe we do need the std.meta.child, I guess, isn't it? Honestly, not sure. Try Lloyd library. So where we're using the in-tray stuff. Can you copy paste, copy paste? Sure. Here we go. Where is it? Where did I put it? There you go. Oh man. Okay. So that's the thing. Self.handle.lookup. Lookup. But honestly, maybe I shouldn't put it like into any kind of struct, you know, maybe just like a helper function. So I think maybe that's what I'm gonna do. But honestly, this is not generic. This is for the handle, exactly. So this is for the entry. But where we're using that, I do not think we even need this exactly. So, well, honestly, hold on a second. I'm just going to comment this out. I'm just going to inspire from it while making the solution. Okay, so here, what we are doing a lot. I think we're doing this guy a lot, this part a lot. So we're doing 2 times at least for now. And basically you pass in it the PFN, and then you pass the name and entry get. Okay, let me just copy this guy and abstract it away into its own function, I think. So yeah. So what this returns? This returns a cd.meta.child vk create instance, I believe. Right. And what we need okay, now we can actually go ahead and see what we have here. So we need the name. And then we need field. I think we need this here, right? And then we need the name here. Now we also have a get instance proc addr, which maybe we could basically call proc. Or we could make this part of, where is this guy? It's inside of entry. Okay, let's put this inside of entry, I think. Or honestly, we'd probably need this for a lot of things. We would need it, for example, for get device, I think. Well, that is a lot of cool, crazy stuff. Okay, but honestly, let's just leave it as a standalone function. Never mind. And this is basically the proc addr. Seems like you might want to pass the return type too. Which return type? And here, comma proc addr, which would be c.pfn vk create instance in this case. pfn could be comp time t type. Now I should have done that if I didn't actually have this trick right here, where I'm basically deriving the type from the name by getting it from as a field from C, you know, and just appending that PFN. So I do not need the type, I just need the name in this case, and I'm deriving the type from the name, kind of. So at comp time, of course. Here the proc addr would be a cdk instance. It would be this, for example, I think. But man, honestly, I would just go with any type for now, I guess. Who cares? So yeah, I think maybe this is the thing. I do not know what to call this. I guess we're gonna call it Lloyd for now. Let me know if there is a better name. Anyway, so let's try to use this now. Where we could use it, for example, here. But by the way, proc addr, I'm going to also have, I'm going to need an instance here. So for example, in get instance proc addr, it would be a vacay instance. Well, I don't know. F will be useful only for vacay create instance. Will that return type? Oh, actually that's true. Well, it's pretty simple. We could just say this. I think, isn't it? Expected after initialization. What do you mean? What? Oh, I require that guy there. Okay, there you go. It's crazy, but I think it works. Here we need the instance or the generic handle, whatever. I don't know, any type. Okay. Now let's try to use this kind of generic thing. For example, here, instead of this craziness, let me just put it in a comment. Okay, so here I could basically say Lloyd, then give the name of the function, which is in this case vacay create instance, and then give a proc addr, which is in this case get instance proc addr. And next it would be the handle, which is in this case null, because we do not have an instance. And hopefully that would work. So expected type found constitute where? Huh? What if I say this, maybe? Okay, this works. Alright. So it seems to work out, weirdly enough. But there you go. I think we have just made a generic function that would work for all cases. So let's try to apply on the other guys. So I no longer need this. Okay, so where else we have needed that? We cannot use this for this one. This is another kind of thing by itself. Well, we could actually have a subset of a function for this particular problem, because we have the same thing happening somewhere around here, cd.meta.child, pfn, etc. So honestly, that's true. Is cd.meta.child here? I think this particular function. Yes or no? Lookup. So if I say fn some function f, I don't know, and we'd basically say return what this would be. So you'd have the name, make another helper for lookups. Yeah, maybe. Oh my god, the coffee is done. Fuel is done. All right. It's, by the way, the middle of the night for me. So comp time name. I've done something wrong here. Yeah, hold on a second. F needs to return type. Yeah, I think. Hold on a second. Where this parentheses ends? Yo, what? It's here, okay. Okay, cool. fnf, I think a type. And then it would return. No, go back, you are so close. Yeah, there you go. So you would get the name and And what should I call this? What should I call this? But let me try to use it first so I can know what. If, let's say, in this case, what it would be name, I guess. Lloyd. We already have Lloyd function here. This will basically get a type of the function pointer. What is this? Plus plus name. Lloyd uppercase. Oh. What is this? Let me try to use it on other stuff. Where is it? cd.meta.child. Here, I think. Return a type in Zig to be upper. Oh, I see. So you could call it F for now. No, maybe I have a problem here. Actually, no. Well, basically, I think it's a matter of saying F and then basically giving it this guy. Okay, cool. Now I could put another function called maybe, I guess, lookup. Or maybe even Lloyd. I don't know. Anyway, lookup for now. And this would give us, I don't know yet. Anyway, so basically this would return library.lookup, that guy. Now I could use fname as the return type of Lloyd. Really? Oh, yeah, I just noticed. Okay, that's cool. Fname. Just like that. Oh my god, look at that. That's why I particularly love Zig. It's just crazy what you could do with it. Especially when we're gonna come to the part where we serialize data types and deserialize them to interact with the to Lloyd data, etc. And that's gonna be the holy grail of Zig. Yeah, anyway. Lookup. Here we have a name. And so we would give it name here, and we would give it name here. I think they should probably be get function pointer or something. Maybe? What do you think? Get function pointer. Basically call it that. And where we're using this lookup thing, here, we're using it here. But sadly I cannot use it in this case because I do not have, or do I? Hold on, what? What this would return first? Lookup. Well, it would, I guess, basically return this guy, no? I don't know. Use Vindiclar identifier library. Oh well, here we need the self. Or basically library. But yeah. So it would be self. Maybe something like pfn-fn. Honestly, I'd like to keep it, you know, readable. So yeah, self, or maybe no need for self. Here, maybe we would just say library is a cd.dylib. Yeah. Yeah, I think that's. And this would be basically a generic kind of helper. And then here, for example, I would just say lookup library and give it the name. I wonder if that would work. I guess let's try. Okay, expected type dynamic library.dynlib. Oh, I think you have to be like this. I think we have to pass a reference. Expected type const u8 found. Huh? What are you talking about? What? Okay, what? I think we have to use that scd.mem.slice too, possibly. In this case, replace comp time const u8 with. Okay, that's right. And well, expected type const u8 here and but found here. So how we would do that then? Maybe here we would say other places too. Where exactly? But no, we do need this thing for the proc ADDR, I guess. Maybe. No? If I do this, what's gonna happen? Line 5. Expected type found. Found const u8. You see, we need that exact thing in proc ADDR. So name.ptr. Well, let's go back a second. If that's the case, then maybe we could. Okay. So what it was all about again? Get function. Oh, so you mean maybe we could do this, and this maybe? And then here in proc ADDR maybe we would say .ptr. Does that make sense? But in lookup here, this name should be kind of a terminated string. Yeah. If I say ptr, would that work? Nope. Maybe we should use that scd.memslice to here. Maybe we would give the pointer and then the end, which is 0. Possibly. All right, works. Perfect. Perfect, that works. All right, that's nice. So yeah, seems all good. That's crazy. We have just generalized that thing. Now let's see what we could do. Where's the other ones? Here. So we're doing this. Okay. Let's just comment this out and let's use that new function. So what we called it again, I think Lloyd. You would give it the name, which is in this case vk destroy instance. You would give it the proc addr and then the handle, which is basically entry.get instance proc addr, and then you would give it the instance, I think. And if we zig build run, there you go, it works perfect. Now I basically have transformed this to this, which is honestly very interesting. Yeah. Yeah. That's very cool. Is there any other suggestion? Seems all good to me. Maybe this could be its own helper function. Honestly, there's no need to put it here, maybe. I think. So you could basically say library names is, well, const, no, hold on, u8, or hold on, should you do like const here or what? Maybe. Is that correct? And then here I could basically say Lloyd library, and that basically pass it the library names. Seems to work. And so now we got some helper functions. Pretty cool. Pretty cool. All right, interesting. So now I think we could go to the next stage. Oh, honestly, by the way, before that, we have to check for other error codes. And well, to do that, we have to go to vk instance create info, and here it would tell us the possible error codes. Do not remember where exactly, hold on. Oh, not this one. In, if we go back, vk create instance. Okay, here. And here's the possible return codes. So it could return on success, vk success, otherwise on failure, it could return this. So you could actually add this. Oopsies, okay. So I need to well, how do I even do this? I posted some code in Discord. Let me see. So check result. What this does, x any type comp time fmt args. Oh, check result, type info, type of x, and if x is less than 0. Oh, pointer, else unreachable. Which test? Oh, here. Well, I think we're just going to explicitly like handle errors. So basically, what would happen is that I would look up the possible errors, and basically put them here. You know why? Because too simply, so everything else would be unreachable. So we were telling basically the compiler that these error codes are what is possible, and then anything else is basically unreachable. It would be undefined, I think. So we're gonna do proper error handling, I think. We're gonna do proper error handling, I guess. So let me see. Hold on a second. So vk create instance, and I would basically copy this thing. So c.vk error out of host memory would be this, and it would be let's see, is it, oh, I'm gonna say error dot out of host memory. This would be very time consuming, but you know, vk error out of device memory, and you would say error dot out of device memory c.vk error. I wonder if we can somehow make this less tedious. But yeah, initialization failed. And then c.vk error layer not present, error dot layer not present, c.vk error extension not present, and if it's a vk error incompatible driver, we could say error dot incompatible driver. And yeah, there you go. Although honestly, layer not present and extension not present doesn't really make sense for us in this cases. We're not using any layers or any extensions, but it's fine. It would be there. It would be useful later on when we have the extension. Copy paste multi-cursors plus VS Code convert case to upper camel. Ooh, that's some interesting setup right there. But yeah. Okay, so, and otherwise, if there's anything else is not possible, or at least shouldn't happen, Prime Agent would love to flex with some macros here. Oh my god, not so good at that stuff. At least not yet, but yeah, anyway. So this is pretty much, we have handled all the errors. Consider using try or catch or if or whatever. What is that? What? Switch. Consider using try, catch, or if. What are you talking about? Error is ignored. Oh, I'm not returning the error? Are you kidding me? Oh, I see why. I see. Well, can't we do this? No? So we should return it here. Should return that, I think. Otherwise though, otherwise you could basically say this: destroy instance, remove this guy, do this, and you would basically have this. So there you go. I think this would may work. There you go. Done. Works. So this is what we have. Amazing. Perfect. This is pretty cool. Pretty cool. So yeah. Nice. Webcam covers latest YouTube chats. I mean, honestly, there's no better place for it. Maybe on top, possibly. But yeah. Okay, pretty cool. Pretty cool. So I think we could go now to the next stages, which is to basically choose a physical device. All right, so how are we going to do that? Choose a physical device. Okay, let's see. I always like to basically start with just doing stuff on the main function and then basically abstracting it. But yeah. So instance dot destroy instance handle the init. So basically have to use vacay c.vacay enumerate instance, I guess, or in device, or thanks like new campus too. Vacay enumerate instance physical devices. So we'd give the instance, the physical device count, and physical devices. Okay, so we have to load this function. So let's do that. Enumerate physical devices. So let's try to load that. Load comp time name vacay enumerate physical devices. Comma, the proc ADDR would be, well, hold on a second, what? Yeah, I think it would be entry dot get instance proc ADDR, right? No, or yeah, well, I don't know. Proc ADDR, and then the handle instance. We already have the instance, so just going to pass in instance dot handle. Okay, so it seems like we require entry, but honestly, we could basically load that function pointer into this guy. We could store entry basically, I think. So how are we going to do that? Or what we could also do, which is to basically say enumerate physical devices is equal to, well, this guy. And then of course here we would just pass the instance as the handle. And there you go, done. So this is how we'd add new function pointers. Pretty cool. Now enumerate physical device. So instance dot enumerate. Sadly, it doesn't seem like we're getting any. Oh, I know why. Well, let's grab this guy here, and we basically need to add the get instance. Hold on, no, enumerate. physical devices, and it would be, let's see, it would be, well, scd.meta.child, right? That stuff. c.pfn vk enumerate physical devices. So yeah, that's how it should be. And now we would say enumerate physical devices. And this enumerate physical devices takes in, hold on a second, I'm going to put this on the other desktop just so it doesn't bother me anymore. And I'm going back to the first desktop. Nice. Same thing with this Vulkan configurator. So I could basically go ahead and quickly tab out to the browser. So I'm gonna do the same exact thing. Put this in the other desktop. Go back, and now oh well, the chat is kind of not allowing me to do that. Well, anyway. Yo, what's happening? Why this thing is here? That's crazy. Okay, cool. I wonder if I can make this window not so it doesn't tab out, I think. What if I keep above others? No, that doesn't work. Doesn't work out. Well, anyways, I just have to live with it. Anyway, so let's have a look into vk enumerate instance. Physical devices. And it basically takes an instance, physical device count, and physical devices, a pointer to an array. And here, of course, we have to allocate an array. Okay, so basically what you do, first you call this function, you give it the instance, and you give it a reference to, as you can see, uint32 to a variable, and it would basically put how much physical devices are available in that variable. And here you would just pass null. And in the second function call, you would do the exact same thing, but instead of passing null here, you would pass in the array that you allocated depending on the physical device count that you got from the first call. Okay, so that's basically it. Alright, let's try to do that. Enumerate physical devices. First of all, we would say instance.handle, and then we would say reference to count. So we would have a count var count u32 would be equal to undefined, and then here we would say null, basically. And let me try to print how much physical device I have. Of course, I have 1 GPU, so it should show 1, I guess. Although it doesn't necessarily need a GPU. I mean, if you have, let's say, for example, a CPU that supports Vulkan API, it would also show that. But yeah. So std.debug.print, and let's see if this works. Let's pass in the count, and let's see what we get. Value of type cint ignored. Oh yeah. Let's ignore it for now. Then Russia airstrikes again in the middle of the night. Where are you? GPUs are also GPUs. Oh yeah, integrated GPUs, right? Exactly, yeah. Zigbuild run. Ukraine. Oh, I see. Well, that's crazy. Hope for the best. All right. VK destroy. I also have a friend from Ukraine. Well, an old friend. We were developing a game on Roblox. He's actually one of the admins of my server. Hold on a second. There you go. There you go. This guy. But yeah, he's also founder of the server. So yeah. Anyways, so as you can see, vacate disorder instance is getting called after vacate enumerate physical devices, of course, and it's succeeding. Okay, so let's actually add a new line there. And you would notice that, there you go, it's actually giving us 1. And let me just go ahead and, for now, let's just not have the, let's just have validation only, not API dump, so it doesn't. And also I would like to disable, what is it called? Info, right, exactly. So yeah, pretty much. Sig build run, and as you can see, we have one physical device because I only have one GPU. Looks like he has the same name as me. Oh, he's also Danila? Or are you Danila himself? I don't know. Anyways. That's crazy. Anyway. Now I'm down. Sig build run, okay. Var count. So yeah, now we have to actually basically allocate an array for the physical devices. So how we would do that? Well. First of all, we need the GPA, general purpose allocator. So let's create one, I think, or honestly, let's just do it where we need it, I guess, which is basically around here. So const, or actually var, general purpose allocator is equal to std.mem.heap, I think, or actually std.heap general purpose allocator. Here you would give it a config, which I would just leave empty, and then you would instance that, and there you go. And then it would get an allocator from it. So yeah, dot allocator. So now we have an allocator, and now we would create an array. So how we would do that? Var std, well, hold on, physical devices is equal to std dot array list, and we'd give a comp time c dot vk physical device, which is basically just an ID, just like a U32, but yeah, std array list, and that's it. Here you basically create a type, and then we would say dot init, and we would pass in the allocator. Nice. Allocator can be const. Sorry for nitpick. It's fine. Const allocator. Physical devices. So now we would let's see. Physical devices. Is there another init function? Hold on a second. Yo, there is init capacity. Insert slice. Okay, you would give an allocator, and then you get the number, which we have, which is the count of the physical devices. And then I guess we would basically, okay, so right now what we're going to do, we're going to call this function again, but this time instead of null, we have to pass it the allocated memory. Now how to do it exactly using this guy, I don't know. Maybe we would say .ptr, not sure. But let's see. Consider using try. Okay, yeah. So I think here try, and maybe even maybe here. No. Okay, let's try hit this. No field named ptr and struct. Okay, so maybe dot items, then dot ptr. Oh yeah, I guess. Yeah, maybe. So how you do it? You would basically say allocator.alloc, and then the comp time, which is c.vacate instance, and then the n is the count. And by the way, I forgot to hold on. So general purpose allocator, defer general purpose allocator dot dinit, and I should of course also assert that this is equal to OK, because if it's not, then that means there is a memory leak. Dot OK. All right, cool. Cool. So I think we could just do this, okay. Now, enumerate physical devices. Now we would basically call this again. And this time we would pass maybe this guy. Does that make sense? On alloc, it would give you error and slice t. Well, slice. So I should basically put give a ptr. All right. Try. Oh yeah. So expected type C struct physical device found. What's the difference there? Well, one is pointer and one is C pointer. Pointer type child. Wrong T. Oh my god, vacate physical device. Oh yeah, I think we have a memory. Oh yeah, address. Oh, it's just memory address leak because we have to dealloc. So defer physical devices dot, well, allocator dot free physical devices. And nice. And there you go. Nice. Now we basically have a list of physical devices. So. Now we have to basically choose a physical device. How you would choose a physical device? Well, let's first go through all the physical devices. Physical device, and we would basically say, let's see, so basically physical devices it could be GPU, could be integrated GPU, whatever, any device that is compatible, that any device with a driver that is capable of or have an implementation of Vulkan, although a confirmant implementation of Vulkan. So for example, Mac OS doesn't have a confirmant API or Vulkan implementation, so it would actually not show up. The physical device of it won't show up. If we want that to work though, we would need to add something. Should we care about Mac devices? I guess so. So how we would do it? Well, you should go back to the creation of the instance. So where we're creating that? Here, right? So here you would say flags is equal to c dot, well, let's see, c dot enumerate portability. There we go. So you'd say c dot vk instance create enumerate portability bit khr as a flag. That's a pretty big name, but yeah, it should be one of the flags. And currently, this is the only flag that is possible for this. The other thing is you have to add an extension, which I honestly do not want to do, but well, who cares? So you'd say extension, well, what is it called? vk instance, hold on. Vk instance create info that enabled extension count and this guy both. So you would say so the enabled extension count, it would hopefully be extensions.len, I believe. And then pp enabled extension names would be extensions dot. No point in supporting Mac if you can't even test it or you have Mac. Well, I do not have Mac, but this should hopefully work. But you have right in that. But if someone have, because this would be open source, if someone have Mac, could basically test it and let us know. So yeah. Extensions dot, I think .ptr, this would be basically a slice. And of course we would have const extensions is equal to const and that maybe u8. Oops, it should be like this. Maybe this like this. I don't know. Doesn't want to do that. Anyway, expected after statement. What do you mean? Oh, I see. So something like this. No, doesn't seem like it want to work. Anyway, so basically here we need the portability thing. Yeah, there we go. So vkkhr portability enumeration extension name, and if you actually have a look into it, it's basically just the string, the name of that thing. So you could basically just put this string, but using this way, it would be, you would have error if you misspell it or something, which is nice. Hopefully this would work. And let us fix this. For now, let's just say equal physical device. No member named PTR in that. Well, isn't it isn't it a slice? No member named PTR in that guy. Extensions may work. Well, that's actually true. Hold on. So it expected the type where this is. So yeah, it's expecting a C. Well, if I say .ptr maybe? No member named ptr, so maybe I should say how. Constitute. Well, what if I use this exactly? Copy. Would that work by any chance? Oh yeah, does not support array initialization syntax. Well, how to do that then? I do remember Andrew code, Vulkan. Yeah, let's see if we can find a solution there. There you go. He's have device extensions, and he's using this kind of thing. Let's see if this works. And it works. So what he did, he added basically this. He added this. So that seems to make it work. So that's nice. That's nice. Can I do .ptr right away here? No. So it have to be like that, a reference, and you give it that. And there you go. Now it's at least could work on Mac right now, although not testable for now. We need someone to test it, but there you go. This is, at least in theory, this is what's needed to make it work on Mac, on Mac OS. Although I don't know if we could say like if Mac OS, then add this flag and add this thing. Yeah. PTR for slices, arrays don't have it. Oh yeah, I see. That makes sense. So you could maybe, for example, like make it into a cat slice and then basically do that. But yeah, anyway, that's nice. Nice. So that's pretty much it for the instance. Let's go back now to the physical device. Now we have a handle to the physical device. What we should do right now is basically we need another function called vk enumerate physical device. Actually get vk get physical device. What is it called? Q families, I guess. Q family properties. There you go. And you basically give it the physical device, which we have here, and you give it a reference to a Q family property count, just like we did before. Q family property count. So I would just say a reference to the count variable, and then PQ family properties. PQ family properties. Here, null for now. First null, and yeah, c.vk get physical device key family properties. Now, if you do not want to do all this sorts of checking and making sure you're using a compatible device and etc., you could basically just go ahead and use the first physical device you get and just call it a day at that point. But let's just do the things the right way anyway. That just returns void, which is nice. So yeah, next up we should basically allocate. This is Q family properties. It would be vkq family properties. And yeah, there you go. Now we would go through all the Q family properties for Q family properties. Q family property. You would notice that I'd like to not make use of abbreviations, etc., to keep the code readable. So yeah, Q family property. Okay. Now, by the way, I forgot about defer in to free that thing. So defer Q family, well, allocator.free Q family properties. Let's go. Now here, Q family properties, now it does have some things like minimum image transfer granularity. You have the Q count, you have the Q flags. Now, basically a physical device have a number of queues. You could think about a queue just like a thread, basically. Each queue could run on its own, you know, kind of thing. Like you could, like for example, the CPU have cores, multiple cores. For example, my CPU have 6 physical cores and 12 logical cores. You could think about queues kind of the same thing, kind of its own core, or kind of a thread, like a CPU thread or something. But yeah, anyway. But each queue, well, honestly, I would want to install something. It's called, I do not remember. Well, let's just look for Vulkan. And it's called caps viewer, right? So -caps viewer. So there's only AUR stuff. There's one. I wonder if the get one would work. There's no votes on it though. Oh man. There's also X11 one, which have 2 votes. Wayland have 44 votes. That's crazy. Let me look into the build files though, just to make sure there's nothing fishy there. The AUR cannot be trusted. Sounds fine. Nothing fishy is there, I guess. Well, let us try if it works. Apply. Oh well. I'm just going to make it invisible for a second there. All right, so I'm a bit paranoid on security. I've seen some things that are crazy. Failure occurred in prepare, aborting. Okay, so that doesn't work. Seems like. Let's try another one. Let's try, I think, X11 bin. Let's see the build files again. Seems all good, I guess. So let's try this one too. Okay, it's trying to build it now. And it successfully have built it. Let's see if we have it now. There you go. Vulkan Caps Viewer. Okay, cool. Now, using this, we could basically look up all the properties of a physical device, of course, from the Vulkan API. All right, and this is pretty interesting. So I have the GPU, I have one GPU here, you select the device. I have GPU 0 NVIDIA GeForce GTX 1650, and nothing crazy there, but yeah. So now we could go to, there's also, by the way, the database. If you go to database, here you could find a lot of reports from other devices, and you could see the Vulkan properties of that device. For example, this device right here, I could look into it. Well, there's a lot of reports, and they could look for one of them. And I could basically check on the properties and stuff of that and capabilities of that device. What features, what extensions, what formats, etc., for that OS, for that driver version, for that, you know, you got the point. But yeah, so my device is already present in the database, but can be updated. Well, I could actually update the database with my device. So submitter, well, I'm gonna say Codotaku submitted in a live stream. Okay, let's go. And the report has been updated with the following information. Nice, thank you for contribution. And that's how you contribute to the database with your own reports. Okay, cool. Now, let's look into key families. There we go. I wonder if the live stream is still fine. Yeah, seems all good. Okay. All right, so I have, in my case, I have four queue families. I have the first queue family. You could think about family just like a group of queues, and each group have some attributes, okay, have some capabilities. So the first queue family have 16 queues. You could think about it as 16 threads. And they are capable of graphics and compute and transfer and sparse binding. Now, if a queue family does have either of graphics or compute, then automatically, implicitly, it have transfer. So the driver, according to the API, the driver doesn't have to tell you that it's capable of transfer if it tells you that it's capable of graphics or compute. That's just something to keep in mind. You could look it up in the API. What is it called? Anyways, whatever it is, anyway. So this is the flags, okay? So graphics, compute, transfer. Here, the second queue family, it have only transfer, and it have only two queues. And also there's another property which is interesting, which is supports presentation. This would tell you, like, if you have a swap chain, which is basically would be in the window, this tells you if you can actually present to it. So you would need that for if you're going with graphics and you want to display something into the screen, into a window, you would need the supports presentation to be true. But yeah, the third one supports compute and transfer and sparse binding, and it also supports presentation. The third key family, or actually the fourth key family that I have, it supports video decoding. This is actually new. I didn't see it last time. I've used Vulkan, so at least I think so. Anyway, supports presentation false, and there's one queue in it. Interesting. So in my case, since I'm only interested into compute, I have to look for a queue family that have the flag compute bit. So that's basically what I need. And also one thing to note is that you could, a GPU could have like a dedicated transfer unit, and that would be very fast. You would use it, for example, to asynchronously load big textures or buffers or whatever. And how you can maybe determine it, for example, here QFamily1, it only have transfer, so it's only capable of transfer. It's not capable of graphics. It's not capable of compute. So the less capabilities you have, the more probable that is that key family is more specialized. So it's more efficient in that particular task. And this key family one have only transfer. And also it only have 2 queues, which also tells you that it's more specialized. So let's say, for example, if you want to sort the key families on the least or the most specialized, you would maybe look for the least amount of queues and the least amount of flags. So I think, of course, this is not a rule. I don't think this is in the API, but this is just something that you could maybe use as a heuristic to finding the most efficient for a certain task. Anyway, so in my case, I'm just going to go through all the queue families and look for flags, key flags dot. This is a nice intro to Vicky for me. I'm glad to hear that. I really struggled to learn this stuff because I just couldn't find a really. I mean, there is some tutorials out there, but I don't know. I have some certain understanding, a way of understanding that is kind of, I don't know. Anyways, the key flags. So key flags dot. Now, key flags is a U32, and so basically, so those key flags are a bit set, should I call them? So it's a U32, which means there is 32 bits, I think. Yeah. So 0, 1, 2, 3, etc. Stuff like that. Now, basically each bit could be 0 or 1. Let's say we have just a 4-bit number, okay? Which means they're gonna be 4 zeros, and then, or 4 bits, should I say. And then each bit could be either 0 or 1. Now, if you have, let's say, some options, you could, for example, tell that this option is for option A. And you could toggle it false or on, like off or on, or false or true. So if it's false, this bit will be 0. If it's true, it will be 1. And the second option, same thing, it could be 1 or 0. And so stuff like that. Now, if we check for c.vk q compute bit, if you check this one, you're gonna find that it's 2, and we know that 2 in binary is basically 1 0 10 basically, so 1 0, which means that compute is stored in the second bit from the least significant, but yeah. So might use because this is a C API. This is translated from C, so everything is an integer. There's nothing called an enum in C. But yeah, so here graphics bit would be the first bit, compute would be the second bit, transfer would be the third bit because it's 4, and 4 in binary is 100. So basically 1 0 0 or 0 0 1. Depending on from where you read it, but anyway, there is sparse binding, which is 8 and 16, and as you can notice, it's going in powers of 2, I think, right? Or yeah, powers of 2, because the first bit would be 2 to the power of 0, the second bit would be 2 to the power of 1, which is 2 to the power of 2, etc. But yeah, so how we could check if this key flags, which is basically a binary number which contains some bits, and each bit can means something, means an option. So how we could check? What is VKQ flags and VKQ flag bits? So Q flags, as I said, it's a number, U32 number, which means you have 32 bits, and each bit could contain an option. So for example, the compute bit is equal to 2, and 2 in binary is basically 10, which means that we can find the compute bit in this, well, we could find out if there is compute by checking the second bit, if it's on or off, if it's 1 or 0, okay? And here's how we're gonna do it. We're gonna AND that with the c.vkq compute bit. This is a binary AND, I think, or what is it called? I don't know, anyway. But basically what happens is that when you say AND, let's say you have some number, whatever number that is, okay? And then you say AND, for example, 0010. Sorry, I know how bit flags work. I was curious what the type of c.q flags is. No problem. All right. But it's good to if someone doesn't understand. But yeah. So this would give us, this is kind of like masking. So if you have a binary number or a number basically, and you mask, you end it with a number like this. This basically means that you only want to preserve the second bit in this case. And anything else you want to basically zero it, which that would give you 0010 in this case. So otherwise, if this is 0, it would give you 0. But the other numbers that are not masked, it would not care about them. They're always going to be 0, because true and true would give you true. But anyway, stuff like that. Anyway, so this is just a little intro on bit flags and stuff. Expected after statement. So here I think we should say if, and if this is equal to 0, that means that the compute is not there. If it's not equal to 0 though, if it's equal to c.vkq compute bit itself, then that means, so if it's not 0, that means compute is there. Now, now we could basically say, I think const physical device maybe. Or honestly, let's just keep it simple. For now, let's just say var physical device. And we would say c.physical device, okay, is equal to undefined. And we could say that here we could say that physical device is equal to the current physical device. Oh, but no, hold on. Let's call this maybe selected physical device. So selected physical device is equal to the current physical device in the loop, and also the selected queue it would be a c.vkq is equal undefined for now. Although honestly, this is optional, because you could find, maybe you do not find the physical device, a compatible physical device and the queue. What could I say? Not compatible, but capable, basically capable of what you want. In my case, I like to have queue compute bit there. Although honestly, when it comes to the Vulkan API, if it's Vulkan conformant, I think any Vulkan conformant device should have compute, at least compute, I think. Although I'm not sure about that, but I think that's the case. But yeah. Otherwise, if it doesn't have compute, then what's the matter? Like, there's nothing to do with it. It wouldn't even be enumerated here, but yeah. All right, so okay, enough of the blah blah right now. Let's just get into it, I think. So this would be optional. And I think it would be null by default, so. Okay, and then here we would basically say selected queue, although this is not the queue itself, it's the queue index. To be precise, selected queue index is equal to Oh yeah, I see. So now in Q family property, you do not get the index. You do not get the Q index, right? But basically you should add here the index of where you found it in the array. So in this case, it's going to be 0 point or how you do it. I do not remember how you do it. What? I do actually indices in indices in Zig. So Zig enumerate and add it to the capture. Oh yeah. So I was getting it right, but it was telling me that it's an error. So I thought it's not valid. So it is actually valid. So you just have to add now Q index. Okay. Although actually it's Q family index. No? Yeah, Q family index. So this should be selected Q family index. That's a big long name, but yeah. And there you go. Now honestly, I'd like to maybe put this into its own struct, because if you find physical device, that means you found the Q. If you found the Q, you found the physical device. So both, you either have both null or both are valid or not null. So maybe we could make a little struct for them. But what we should call them, I'm not so good at naming. Let's see. I guess maybe Q family is equal to a struct, and then you would basically have physical device, I guess. U32. And then I feel that you'll have awesome Vulkan tutorials and decide to make some in future. I mean, this is a Vulkan tutorial kind of, although it's not. I mean, honestly, even my videos are just like this. It's just kind of like a live stream, but it's not. Because when I come to actually, record videos, I just press record. I do not prepare or anything, because if I try to prepare, I'm not going to record that video. I mean, I'm not going to upload that video, because I'm going to keep on re-recording that video because it's not perfect. So I keep on re-recording until I do not upload anything at all. So that's why I just like to press record and just do it. Just explain. And it's more productive like that. So yeah. So live streams, I think, are perfect for me. And also you get feedback from other more experienced people. And yeah, that's pretty much it. Okay, so here we could basically say Q family physical device Q family. So you could say that Q family is Q family, although it would be optional. They would say Q fam. Oh, what I'm doing. Well, it's going to be null, basically. And then you would say that Q family is equal to point, and you would have dot. Oh, I didn't add Q index. Oh, what I'm doing. Hold on a second. C.vk physical device. And here C dot. Oh. C.vkq. Let's go. VKQ. All right, cool. Although I think maybe, no, actually no, my bad. Okay, this should be U32 because it's not the queue itself. We're going to get the queue later on when we create the device, but anyway, but this is just the queue index really. So yeah. Dot physical device is equal to 222 to the physical device, and dot q family index, or what is it called? Q index. Well, it's actually not Q index, but Q family index, right? Okay, there you go. Pretty much. So if we found a good device, a Q family in device for us, there you go. Done. I think that should work, hopefully. What I'm doing. Expected type U32 found U size. So we should basically say make this into a U32. How you would do that? I think as U32. Yeah. Would that work? No. So maybe we should int cast to U32 and then give it the, what is it called? The Q family index. Does that make sense? And in defined symbol, vacate get physical device key family properties. So you would get an indefined symbol for that because we're not linking Vulkan statically. We're not linking it from the build.zig, you know. We're actually loading that manually from the thing. So let's load actually this this guy. And do we need another function? No, it seems like this is the only one that we need. Okay. So let's actually load this one too. So dot get, what is it called? Get physical device key family properties. Get physical device Q family properties is equal to Lloyd entry dot, well, dot get instance proc addr and then the instance. And there you go. Now instead of this, we should say instance dot get, what is called, what I called it, hold on. Oh, I should actually also add it here, my bad. Get, and this is basically std.meta.child, you know the drill. pfn vacate get physical device Q family properties, and there you go. Now hopefully we could actually say get physical device Q family properties, and they should work. Ta-da! Let's go. Now let's see if we got the Q family or not. We should, but let's see. So if Q family, I guess, well, we could say maybe is equal to null, I guess. Or we could say basically assert, no. Let's just say if Q family. And I don't know what to call this. Maybe I should call this optional, for example. I do not know a good naming convention for this, honestly. Because basically in Zig, you cannot actually shadow a variable, which is kind of annoying because you constantly have to come up with another name. But I should come up with some convention for this kind of way of doing things. But anyway, so opt Q family is very common, or MQ family. Okay, so I would go with optional. Maybe Q family. That's nice. Okay, maybe Q family. That makes more sense. Okay, Q family. Now let's actually std.debug.print. Let's say Q family dot physical device, and then Q family dot Q family index. Let's see if this runs correctly. And of course I do need this. Oh yeah, I need this guy. I need the specifier. Huh? What is optional though? Well, there's nothing optional here. Maybe this one? Maybe the physical device though, maybe. Yeah, it is. Okay, so that's pretty much it. New line. And there you go. So we got a struct fake a physical device, and we got 3 for the Q family. Yo, why 3? Are you kidding? Hold on a second. What? Maybe I mean, it should take the first. Use typed structs instead of anonymous when possible. You return anonymous struct in function that creates fake instance. Use typed structs. You return. I'll have a look into it. Let's see first why this doesn't work. 0, 1, 2, 3. It's returning for me. Something is wrong, I think, here. Q family index is 3. Why it took the last one, which actually doesn't have Q family bit, Q compute bit, you know. So, and not equal to 0. What? How? I think something is wrong here. Maybe forgot to break. Oh yeah. That's correct. That's correct. So if you find it, we have to break. Although honestly, I do not know why it says 3, because it doesn't even support compute. That's weird. Anyway, so a break seems to work. So yeah, there you go. We got the first key family index, which is correct. Nice. If I say equal, it would give me the first one that doesn't support compute. What? None of them doesn't support compute, or what? Oh, what I'm doing here. Actually, it's not really. Hold on, what the? Really? Well, there is. Hold on. Well, there is key family 1 doesn't support compute, so it should give that. Really? That's crazy. Something is weird here. I honestly do not see what's weird here. Let's just keep it for now. Anyways, kind of weird. Anyway, so that's pretty much it. We got the Q family now. Now I think it's the time to create a device. Basically, we have chosen a physical device when we have chosen a key family. Cool. Although before we do that, of course, let's kind of try to make this into its own function and handle errors. So enumerate physical device could have a result basically. So let's handle those. And yeah, I think those are the only errors we have now. Yeah, seems like nice. So let's look up those guys. Vacate enumerate physical devices, and let's check up on the stuff that is, yeah, there you go, error out of host memory. Yo, what's going on here? Man, that's crazy. Oh, I see what's happening there. That's annoying. Anyway, let's just say something like this, I guess. What? Okay, keep above others. So, okay, cool. All right, cool. So now we have to basically switch on this. Switch on that guy, and if it's vacate success, then basically we have to return an error dot out of host memory. Otherwise, if it's also if it's vacate incomplete. So vacate incomplete is also a success. And vacate incomplete is basically telling you that you didn't get the whole thing, which could mean that the driver somehow, weird stuff, but yeah, basically it didn't give you the whole thing for some reason. But from now, at least, I'm just going to ignore that and just going to consider it as a success. And yo, what's going on here? If that's the case, then well, we're not gonna do anything, I think. Or is it? Yeah. And otherwise, if it's c.vacate error out of host memory, we're basically going to return error out of host memory. If it's error initialization failed, we're going to give it the initialization failed. Okay, nice. Otherwise, other than that, it's unreachable. Okay, that's that one. And of course, for now, at least, I'm just going to do this. Just going to ignore that. And the other thing is here. Well, it's basically the exact same thing. So we're just gonna copy this guy for now, and we're gonna say this. And yeah, let's go. Nice. So now I think we could put this into its own thing, into its own function, I guess. So maybe, let's see, instance, okay, fn init and the init. After that, let's say fn enumerate instance, enumerate physical devices, and you would do this, and this should return this guy, which is going to be which is going to be what? First of all, we need the instance. Which is basically self, right? And we need an allocator, which is going to be std.mem.allocator. Other than that, we're going to return either an error or a slice of c.vk physical device. And of course, we're going to return this guy. And for this one, if we have an error, I want to basically propagate it, like return it. If otherwise, I'd like to basically, So how to do this? A return is fine here, but here we cannot return. Here, I think maybe we could catch, or what? Maybe we could try this? Yeah, maybe? So, let me remove this now. Use of undeclared identifier physical devices. Yep. So let's actually get the physical devices here. Is equal to instance.enumerate physical devices. And of course we need the count thing here. So let's say var count v32 equal null. Undefined. Expected 3 arguments. What are those arguments? It needs allocator. Oh, what's going on here? Oh, I see. I called it enumerate physical device. I see. Well. I need to name it something else. So, honestly, maybe I'm going to start to prefix those raw functions with something like vk, I believe. As to keep the abstractions. Well. What do you think? Should I do that? Or in this case, maybe I could just say get physical devices. But I'm not sure if it's a good in the long term when we're going to have the same problem in other places. But yeah. Get physical devices and pass it the allocator. Found void. Can I remove this pointer thing here? Let's try this out. And Z will run. Now here it needs some kind of return type. What we should do here. Maybe catch. Does that make sense? Expected space statement without catch. I mean, I could do that. Is there a better solution? So you do not have to say like return this and return that. You would just list the errors. I wonder if that's possible here. Catch E, return E. So catch error, return error. Then, well, can't we just do this then? Why this doesn't work? Still same problem. So this doesn't seem to be, so I'm just gonna go with return anyway. So yeah. What? What's this talking about? That's honestly so weird. So it's expected get physical devices .fn.return time found void. What? What if we do this? Well, that's no. This is crazy. Declared here. Do you guys have any idea how to fix that? Ooh. Well. Just void with catch. Yeah, it can error, right. Error. What if I do this out of I guess this seems to work, maybe? That's weird. Error is discarded. Consider using try. That's crazy, man. Try? Any error? Oh. I didn't even knew that existed until now. Catch after switch statement. Bruh, come on. No. This is such a basic thing, man. Weird. Let's ask the Discord. Let's see. This is the code. Add try before. No. No, enumerates physical devices is a C function. It returns basically an integer value. If it's vacant success or vacant incomplete, well, success. Otherwise, you have a problem. So, yeah. Try switch. I think I've done this before, but it didn't work. There you go, same problem. Honestly, I think I'm just gonna use if. That's weird. So const status is equal to this. If status is equal to c.vacate error out of host memory, then return this. Else if or elif or else if status equal to c.vacate error initialization failed, then oh, so how exactly? Try switch. Oh man, I removed that thing. Same problem. If we return weird. Also, I'm just gonna use a regular if statement at this rate. So let's just remove this. Or honestly, instead of removing it, well, anyway, never mind. Just remove it. Return error dot initialization failed. Okay. Instead of status, let's call it result though. I mean, come on, really? What's wrong again? What? This is crazy. It's actually telling us about this for some reason. Oh my god, are you kidding me right now? Are you kidding me right now? This is so stupid. My god. The problem is here. I should actually return physical devices. Oh man. I mean, come on, really. Segmentation fault. What? Why we got, oh. Oh man. I see, okay. So I need this, yeah, this wasted time. Oh man. Okay, defer allocator free. Finally. Oh, was this a problem? Hold on. Let's try to do this again. Using switch. So, if it's c.vacate success or c.vacate, let's see, incomplete, then do nothing. If it's vacate error out of host memory, then return error out of host memory. Otherwise, if it's c.this, then return this. else, well, unreachable. Now let's try to comment this out. And this worked. So the problem was here, and we were just trying so bad with this guy. Oh my god. Oh man. Var count. It's my bad because I wasn't checking exactly where that error is happening. Because if I checked, I would constantly knew that it was here. But man, anyway. So that's crazy. Okay. So we no longer need this. Although I would try to see if this would work without the returns. Oh wait, classic. Oh my god. Try. Would this work? Yeah, this also works. Man. Oh my god. We have just wasted a lot of time for nothing. Man. Anyway. Although, okay, cool. This is pretty much it. Get physical devices. And you basically defer allocator.free physical devices. Now next up is this guy. Zig errors needs to be improved before 0.12. Streaming steals your brain. Yeah. You mean programming, I think. Okay. Let's do this. For maybe Q family, both. Both, yeah, that's true. Maybe Q family. So here we basically should choose a Q family. I'm gonna call it select, I guess. Select Q family. So yeah. And here would give back either a Q family or nothing. So physical device. So here you need the physical devices, which is going to be, I think, a slice of c.vk physical device. And you also need instance. Instance. Yeah, which is basically self. Hold on, what? Well, I should call this self. I agree, lots of errors message could be improved, but this one was tricky because of the duplicated code. Yeah, duplication is evil. Okay. Self, vk, self. Here, self. Here we need an allocator. There you go, we got an allocator. So basically we need self, we need physical devices, and we need the allocator. And we could also go further and maybe generalize this on other stuff. So you could basically say the key family that you, I guess, want, which is basically going to be a cint. Hold on, flags, q flags. It's gonna be a cint, I think. Maybe you could just do this and not equal to 0. But that wouldn't really check. So how you would do it, basically would say q flags. Now if we do this, it would actually trigger if one of those q flags are there. But we want all of them to be there. So a better one would be to do this is equal to q flags. Because if so, that means they're all there. They all exist. So yeah, it depends on if you want one of them to exist or all of them. So since we want all of them, I think, then we could do this. Okay, cool. Cool. So now what we could say, instead of maybe q family, we could say instance.select key family. Here we pass it the physical devices. Makes sense now, good catch. Yep. And allocator. And the key flags here would be c.vk q compute bit. Now you could also basically say plus and then add another bit, you know, like graphics or whatever, I guess. So yeah, and hopefully this would still work. Of course, it never works on the first try. Okay. Oh yeah, because this could return an error, I guess. Where is the error? Oh, try. Okay, I see. So this could return an error. Expected utype u32 found cint. Oh, okay. u32, sure. Now control flow reaches end of body here. What? Try and remove the error. And control flow reaches end here. I think because we're not returning anything, I should probably return null at this point. There you go. Cool. Nice. Instead of break, maybe we could say return. Oh yeah, well, that's true. I mean, in fact, we should do it, not even true, we should do it. So we should say, instead of this, we should say return. And there's no need for this. Okay, nice. Let's see if this works, and let's go. It works. Nice. Amazing. And yeah. You could also have another parameter maybe. You could like say if all required, like is all required, and it could be maybe, for example, Boolean value. And if is all required, then we should check for another condition. Now we could check for condition, and oh, what I'm doing. No, this is not how it should work. So depending on that, we need to do a different thing. So if it's all required, well, here's what I think I'm going to do. Maybe it's all required. And is there like a ternary operator in Zig? So basically, if it's all required, then we should do this. Otherwise, we should do this. So basically, this would be a switch. So if you want all the key flags to be there, then you would basically do that. Otherwise, if you just want one of them, then you would do the other way around. Honestly, I think this is not needed. What do you think? I think this just makes it... anyway, let's keep it simple, I think. So yeah, there you go. I just need parents. Anyway, let's just not do that. I think this is fine. Okay. So we're trying to select key family. I wonder if we could avoid maybe allocations, or I don't know. Anyway. Instance select key family. Now we basically have the key family that we want. Now I think it's time to basically create the device. Cool. Cool. Select key family, defer. Okay, so I'm freeing that. Cool. All right, pretty cool stuff. So my brain is shutting down at this point. So it's 3:26. Yeah, we still have a bit of time. Hopefully we could finish up the device in this stream, and we'd pretty much be done with the... But hold on, and we'd pretty much be done basically with kind of like the context, the equivalent to OpenGL context, kind of, you know? So yeah. So the thing is, if we go back, I just want to check out something now before actually creating the device. Because at this point we're done with the instance level of stuff, I think. Maybe? Hold on. Because at this point, basically, we have chosen the physical device that we want. Which means that we have chosen the driver, the exact driver that we want. So we should maybe use another kind of function to load the function pointers, maybe. Let me check. If we go back to this kind of thing, so there is wget instance proc address, which I believe we are using right now, and there is wget device proc address. An even better solution would be for an application to perform on device functions. This further optimizes the call chain by removing the loader altogether in most scenarios. So I think right now it's the time to actually do this, maybe. Let me maybe research further on this one. Okay, in order to support systems with multiple Vulkan implementations, the function pointers returned by wget instance proc address may point to dispatch code that calls a different real implementation for different wget device objects or their child objects. The overhead of an internal dispatch for wget device objects can be avoided by obtaining device-specific function pointers for any commands that use the device or device child objects as their dispatchable object. Such function pointers can be obtained with the command wget device proc address. You would give it the device and then the const char name. Now I think in this case maybe we could give null here. The table below defines the various use cases for vacate get device proc address and explicit return value for each case. A valid return function pointer must not be null. Description. Anyway, so the device could be null. Means any presentable value for the parameter, including valid values, invalid values, and null. Return value undefined. Okay, well. So undefined. So you need, so if it's a null or invalid device, it would give you undefined. If it's a device and p name null, so the name of the function you're trying to get, it would also give undefined behavior. But if the device is there and it's valid, and you requested the core version, device level dispatchable command, then you would get your function pointer. If it's an enabled extension device level dispatchable command, then you would also get the function pointer. Any other case not covered above, null. Although I don't know what would be that case. But yeah. So that means that we have to have a device, and it should be a valid device in order to be able to use vacate get device proc address. So that means we're still not able to use this guy yet until we create the device, which is going to happen now. Okay, so we do not have to worry right now until we create the device. Then we have to actually use another function. Okay, cool. Nice, amazing. Perfect. I wonder if the stream is in a good quality still. Yeah, it's fine. Pretty cool. Cool. It's already around 4 hours. Oh man. This is how explicit Vulkan is. Okay. We still do not even have the equivalent of a context in OpenGL. Okay, cool. Okay, cool. 0 dropped frames though. Yeah, exactly. All right, so let's go to the next one. So right now we need to create a device. How we're gonna do that? Well. For now, I think instead of having this if condition and stuff like that, maybe I would just say const q family is equal to this guy, and then you would just do this, and then of course try statement or whatever it's called. Anyway. Okay, cool. Let's make sure everything is still working fine. std.debug.print qFamily.count. Let's go. So I think maybe we do need parentheses. Yeah, Q count, I think. No? Oh, key family index, sorry. And there you go. So it's 0, which is correct. Nice. Now we could go further. So next up would be c.vk create device. There you go. It needs the physical device, which we got. And it needs the pcreate info of type vk device create info. So create info, info. And then the allocator. Well, the allocation callbacks, right? So where's the allocation callbacks? So here info, and here allocation callbacks. I think it's in the instance now. But the thing is, you could have a different allocation callbacks on each one. So for example, you could have, for the device, you could have its own allocation callbacks. You could have an allocator for each one, but the most important thing though is that the allocator you use to create an object should be the same as the allocator you use to destroy an object. And also another fact that I just knew recently, which is the fact that if you say null, I believe, at least from what I understand, is that it would, instead of using the driver, it would actually climb up the tree of the objects, which it would be in this case after the device or before the device would be the instance, and it would use the allocation callbacks you passed there instead. But yeah, in this case, we're just gonna say for now const allocation, or honestly just say null for now here, or no, let's just go with this const allocation callbacks. So c dot vk allocation callbacks is equal to null. So p device. Instead of null here, let's go with the allocation callbacks, and here we're gonna get a reference to a variable of vk device. So var device of type c.vk device is going to be equal to undefined. And also, of course, we need the info. So const info is equal to c.vk device create info. And this is a bit involved. But yeah, let's go. And we're going to use that kind of trick that we did before that Travis, I think, showed us, which is std.mem. It's a very nice trick. std.mem 0, I think. Yeah, 0 init. There you go. std.mem.0 init. std.mem. Okay, c.vk. By the way, is 0 init comp time? Well, it seems like, I guess. Yeah, I guess so. Seems like. Alright, so here c.vk device, I believe. Create info. Okay. Cool. Now let's have a look into the vk device create info. What is it like? Okay, let's actually just copy this guy and let's do this. Alright, so the S type would be equal to c.vk structure type. What is it called? Device create info. That's the first thing. Pnex will be null. Flags, I think 0 for now. Q create info count, that's needed. Q create info count. This will be called, well, Q create info count. Q create infos.len. It would basically maybe have some sort of array, I guess. So const queue create infos is equal to, well, it's a cconst of vk device queue create info, I believe, and they should basically contain a bunch of vk device create infos. In my case, we're gonna have only one. So we're gonna have c.vk device queue create info, or maybe I think we could probably just do this, I guess. Maybe, I don't know. What's this needs? This needs this. I hope that the autocomplete of Zig would be better. It would have really boosted, like shrink the time that we need to do this stuff. But anyway, s-type is equal to c.vk structure type vk device queue create info. Let's go. Nice. Next up, pnext, it would be 0. Well, I guess we have to use 0 in it. For now, I think maybe no need. I'm just gonna do it automatically, like manually here. Pnext null flags. Well, I don't know honestly about flags, but I think for now it's 0. And then the key family index, which would be the here where we have to actually give it the thing that we got. So queue family dot queue family index, and then queue count. So this is how much. So recall that here, when you choose a queue family, you do not have only one queue. Each queue family have, like, for example, here you have 16, here you have 2 queues in that family, and here you have 8, etc., etc. So here you basically tell Vulkan how much queues you want from that family. So yeah. Hold on, what the? Queue family index like this. Queue count is equal to, well, here I'm just gonna say 1 queue for now. And we need queue priorities, pq priorities. And notice that this time, although this is an array, it didn't ask for the count of how much priorities you want, because it would infer it from the queue count. So yeah. PQ properties. Here we need an array, and you basically tell, what can I say? You basically give each queue that you requested a priority. But here we have only 1 queue, so it doesn't matter what you do here. Like, doesn't matter what value you give, because priority only is relevant when you have multiple queues. But if you have 1 queue, well, if priority is 0, priority 1 doesn't matter. So there's nothing to prioritize over another thing, you know. So queue priorities. Here we need an array, an array of F32s. So how you would do that? Let's just say queue priorities, I think. And I I believe we have done it like this before. And honestly, since I'm just gonna say queue priorities dot len here, const queue priorities is equal to, well, just like we'd done it before, I think. I do not remember where we did that. I think, yeah, in extensions. Here, there you go. Well, it's not the exact same thing though, but yeah, it's not relevant anyway, because here we just have F32s. So this, and then basically I think const. Do we really need const here? I do not think so. Do we? No idea. Anyway, maybe we do, but anyway. So here we could say 1.0 or 0 points, it doesn't matter, whatever value, as long as you have one queue. The priority you give there doesn't matter. So yeah. And hopefully that would work. But we should, of course, keep going. So now we have the queue create info count. Now pq create infos, let's go, is equal to queue create infos dot ptr, is it? No, I think it should be like this. Oh, should this be something like this? Weird. Anyway, okay, fine. Queue create infos. Next up is enabled layer count, which of course we're gonna set to 0. Enabled extension count. I think you would enable a swap chain extension here if you're going to use it, but in my case we don't have that. I do not think you need enumerate portability again in this case, so enabled extension names. And this, well, in fact, since we have that 0 in it, we do not need any of this. I forgot about that. Okay, pq create infos, enable layer count, extension names, enabled features. I'm not sure if we can leave this as null though. I wonder. Well, we could check it out on the documentation. Let's see if that could be null or not. Is null, okay. Nice. So that's, I think, pretty much all we need in this case. Let's see. Found calm time floats. Well, how would you make it? That's weird. How would I make the F32 then? I think we could use maybe as here. Honestly, I do not know. That's an array slice. Do you just want an array of floats? Yeah, an array of floats. Oh, I see. Okay. I bet. Okay. As comp time. Do we have to do it like this, or there's a better way? I do not really see. Not really see it. But let's see if that actually persists. Hold on. 1.0. Oh yeah, it needs to be like this. Oh yeah. So we do not need const 2. That makes sense. Same thing here, I guess. P allocator. What? Why this is like a slice? That's weird. It needs to be just one allocation callbacks. What? Create device. Hold on. Let me go back to vacate create device. Oh. Oh, never mind. Oh, I see. So it needs to be a pointer. Hold on. I see. Okay. So this needs to be a pointer. I forgot that. Value of type C ignored. Okay, C int ignored. Well, we gotta switch again on this guy. And well, we need the success. We need the error codes. There you go. So I need to put this here. Thing is, I do not need this guy. I don't know why I was wearing it. Okay, so c.vacate success or c, well, that's just that. Okay, so if that's the case, well, we're not gonna do anything. If it's c vacate error, well, honestly, for now, since we're not making it a function yet, let's just ignore the error code for now until we make it into a function. So yeah. And of course we need to load the function pointer for create device. But right now let's just try if this works even. Okay, and define symbol. So now we have to actually load it. So we need vacate create device. And I believe in the instance, right? I mean, we do not have anything else yet, no? Yeah, I think it makes sense here. So, create device. c.pfn vacate create device. Create device. Now we should do the same thing here. Honestly, why we have this allocation callbacks here? Let's just have it on the top there. And now we could basically say, oops, where I'm gone. Okay. Well, anyway, dot create device is equal to load the name, which is vacate create device, and the proc address, which is entry.get instance proc addr, and then the handle, which is the instance. Okay, cool. now we have to say the other nice thing about actually manually loading the functions other than performance is that you get to control exactly what you want to call your function. So since the create device, and there you go. But we have, of course, an object leak, and because we have the Vulkan configurator on, which is here, as you can see, and it's set to validation, we get validation layer errors, which means that if we're doing something wrong, then it would tell us. So for example, here the validation layer told us that there is an object leak. The fact that we created the device but we didn't actually destroy it. So as you can see, vacated device has not been destroyed. So this is very useful. So now we also have to destroy the device. Now I think here where it comes to actually get the function pointer of the device level. So yeah, now I think we get to create another struct called device finally. So yeah, const device is equal to struct, and of course this would have as always const self is equal this, and var init fn init, which would give either an error or a device. And fn dinit, which would give void. Cool. So now, this is the creation of the device, I think. We do not need this guy. And this is the whole creation of the device, seems like. Allocation callbacks, key family. So here you would need the key family. Key family like this. And you would need the instance too. What I'm doing, instance. And of course the allocation callbacks. So and there you go. Nice. So now I think we get to do a switch statement here. And of course we're going to return this guy. And here we're going to do if it's vacate success, then well, we can do a lot of crazy stuff. Otherwise, well, unreachable. We're going to deal with the other errors later on, but for now let's deal with success. Let's inspire from the instance. So now we gotta load stuff up, but we need the git instance proc attdr. Which in this case it is getting it from the entry. Now that means that should probably be done from the instance, right? I think so. So basically I guess we have to say get device proc addr is equal to Lloyd vk get device proc addr, and you would say, I guess, entry.get instance proc addr, and you would also give it the instance, of course. And with that out of the way, you would say you would return the actual thing, and of course we need the handle, which is going to be a c.vk device. Other than that, you would have the allocation callbacks. That's also should be done. Allocation callbacks, which is going to be a c.vk allocation callbacks. Okay. Other than that, you need the vk destroy device. So destroy device, which is going to be okay, std.meta.child c.vk destroy device. Oops. And let's go. No, what I'm doing, hold on. Yeah, I think it's right. No, pfn, okay. pfn. I knew something is wrong, but I didn't know what. Okay. And there you go. Now here, we're going to return what? We're going to return handle, which is going to be equal to device, and allocation callbacks, which is going to be equal to, and we need those allocation callbacks for later allocate, like for example to destroy the device. Allocation callbacks. The other thing is other thing would be the destroy device. And here we're going to use Lloyd vk destroy device. Proc addr would be instance dot get device proc addr, and the handle would be the device. But yeah, so that's, I think, basically it. Cool, pretty cool. Yeah, I think that's it. So here we have to get self, and we basically should say self.destroy device. Do you know what the pfn prefix indicates? It indicates pointer function. Yeah, pointer function, I think, because it's basically a pointer to a function, right? pfn, it's that prefix is very used. It's basically the convention when you want to declare a function pointer in type in C. So yeah, destroy device would take, I believe, probably self.handle and self.allocation callbacks, and that should be it, I think, hopefully. So I think I didn't add that type. Yep. std.meta.child c.pfn vk get device proc addr. Now it works. Now let's make sure to create a device and stuff like that. So do we really need this anymore? No, we do not. So queue family, and after that we need to say const device is equal to let's see, try device.init. You would give it the instance, you would give the queue family, it would give the allocation callbacks, which would be in this case null, and then you would defer device.dinit. Let's make sure this works, and done. Do you know, okay, so the different backends X11 will and provide different function pointers. We do not have X11 Wayland here. The thing is, here we're working with the graphics drivers and the Vulkan loader. What do you mean? So yeah. So basically, the drivers are actually defining or implementing the API, and so you would get those Vulkan functions from the drivers. But now, when we loaded that dynamic library, we have loaded the loader, okay? The loader of Vulkan. And that loader, its job is to basically figure out the right driver to call, or to give you the get device proc address or a get instance proc address. For example, in this case, get device proc address, this would essentially give us the function pointer directly, exactly to the driver. So we do not have to go through the loader, and then you would have to figure out who created the device, etc., or whatever, to actually figure out which driver to redirect this function call to it. So we do not have to go through the redirection. So for example, vacate destroy device, we load in it here. This is probably pointing right into the driver, I think. So yeah, and pretty much we have finished the context, the equivalent to a context in OpenGL. So we got the entry, the instance, the physical device, and the device. That's pretty interesting. Oh, I see. I was looking at /usr/include/vulkan.h and saw include guards for X11, Wayland, etc. Well, you would need those for the swap chain. So there's swap chain extension. So now, if you want to basically render into a window, you would need first of all to include the swap chain extension, and maybe I think both to instance and to the device info. And after that, you would actually give, depending on which platform you are. For example, if you are on Linux, you would give a handle to the XCB connection, for example, or the X11 display. So there's different structs for each one, for each platform, and that's why there is those include guards for X11, Wayland, etc. So depending on the platform, you could actually so there is platform specific stuff to actually make a surface, and a surface is basically the abstraction of Vulkan over a window. And to create that surface, you have to use the proper struct depending on which backend you want to use for the display. If you're on X11, there's an X11 thing. If you're on Wayland, if you are on Win32. So yeah, that's it. But in this case, really not even trying to go that way on the surface and swap chain and stuff. I'm trying to basically figure out only the core of Vulkan. The first version without any extension, nothing. Although we did make an exception for the enumerate portability, so this works on all platforms, including macOS, hopefully, at least in theory. So yeah, although someone who have macOS should actually try this when it goes open source. So yeah. Okay, cool. Cool. So basically this is the first thing that any Vulkan application should do, really. It's kind of like here you got a context, and I think it's a good, maybe it's the good time to create some kind of context struct. Basically you would have maybe you would have like, I'm not sure, let me know if this is a good abstraction or not, but basically you would have a context, and it could be a struct, then you could have like an init function, and you would give either an error or a context, and then you would have a dinit function, of course, which could be a, which would give a void. And basically what this would do, it would create an entry, it would create an instance, I don't know why entry is a variable, but anyway, and then it would it would go ahead and do the physical devices stuff, and then it would select a key family, and it would create a device finally. And of course you would have okay, let's see what we got. Of course we need an allocator here foremost, and it would be a cd.mem.allocator. So const device. Okay, and it would have like some fields. It would have the entry, which is going to be an entry. It would have the instance, which is going to be an instance, and it would have the physical devices. Although we do not really require to keep them, we're not required to keep them, since yeah, exactly, honestly, yeah, we're not required to do so. I'm not sure if I want to keep this physical, but for now I do not need them, so I'm just going to get rid of them. So basically defer defer allocator.free physical devices. So we do not basically need them after we have selected the key family at that point. So yeah. Okay, cool. So now we also need not physical devices. I'm gonna go directly, even key family, we do not really require to keep them up, because that's not allocated and it doesn't have to be destroyed either. So and we need the device to keep it up, so we can also of course destroy and stuff. And in fact we do need the device at the end of the day. So dinit, and yeah, now we would just return. And oh, by the way, we have to say const self here is equal to this. This would be error self, and return. You would have the entry is equal to entry, instance is equal to instance, and finally device is equal to device. And finally here you would say, of course you need self. Here we would say self dot, where we'll start by the latest created thing and keep on going like that. So if we created last the device, we should destroy it first. So first in, last out, kind of. First in, last out, I think. Okay, anyway, so self.device.dinit, self.instance.dinit, and self.entry.dinit. And with that out of the way, could basically remove all of this craziness. And on the magic of abstraction, you could say context is equal to context.init. And oh, I forgot about the allocator. So const general purpose allocator is equal to cd.heap general purpose allocator. You would have an empty thing there and that, and then finally const allocator is equal to general purpose allocator. Let's go, and finally defer context.dinit. And we're pretty much done, I believe. And of course there is errors. That's part of life. Okay. Expected type is cd heap purpose allocator. Oh yeah, this should be var, I believe. No field or member named the init in. Yeah, we should try this out. And cost discards qualifier, they should be var. What? I think they should be like this. And there you go. Done. Finally. So yeah, we basically we're done with the context. So that's very interesting. I cannot believe this. Okay. So if we look into API dump, and let's make sure everything is working correct. Oh, I think we didn't actually handle all errors. Yeah, that's the last thing to handle there. And there you go. This is all the Vulkan function calls we are doing. First of all, we're creating an instance. As you can see, we get vk success, then we enumerate the physical devices success, and then this only returns void, and here's success, and then void, of course, because these are just destroys. And of course we're destroying the device, then the instance, and of course the entry. And yeah, pretty much. Now I think the last thing that we have missed is basically handling all the errors of the device, which we're gonna do right now. right around now. Vk create device. Is it or no? Yes, this is it. So if it's error out of memory, vk error out of host memory dots what I'm doing error dot out of host memory. Otherwise you could get a device error out of device memory, error dot out of device memory, and then finally not finally, but vk error initialization failed, error dot initialization failed, and c dot vk error extension not present, error dot extension not present, and c dot vk error feature not present. Again, some errors aren't really needed to handle because they should never happen since we're not using such things. For example, we're using extension, but for example, we're not using features, and also extensions, although this could happen, but the thing is, we're already making sure that should never happen. But still, I mean, if something we change something in the future, we shouldn't bother again with this kind of thing, because you could easily forget about this, and there's honestly no need to not complete this. Anyway, feature not present. c.vk error. Too many objects. Also, for example, this one, we should not get this as long as we're creating one device, but... And finally, vk error device lost. I think this was what happens when you unplug your GPU while your computer is running, I guess. I don't know why I would do that, but yeah. Or maybe the GPU malfunctions, like, somehow it just breaks while you're using your computer, I guess. That would be a bad day. Hopefully it wouldn't happen. But yeah, device lost. And it could be, for example, that the driver actually malfunctions instead of the hardware, who knows. But either way, you lost the device. Maybe, for example, also an update that happens to the driver. Well, there's a lot of things that could happen wrong. So yeah, pretty much. So I think we're done with that now. Let's make sure everything is still working fine. And yes, it does. Let's make sure there's no validation messages that we have to handle. And again, no messages. So there you go. Honestly, very amazing. Try context init allocator, dinit. Q family. So yeah, pretty much handled everything. Is there any suggestions? Of course, we're not gonna, I think I'm pretty much done with adding features. Just if there is something tiny that we could add or fix. Good stream, I learned a lot. Is there a repo link? Sure, I'm about to do it. So, get in it. using master as the name for the initial branch, blah blah blah. Names commonly chosen instead of master or main trunk. Get branch dash m. So I'm gonna call it the main branch, and let's go. Now we're just going to, I need the git ignore file. We're going to ignore zig cache, I think, and we're going to ignore zig out. And also, I think I'd like to ignore c.zig, because I would like everyone to basically translate the C imports themselves, because the Vulkan header could change, I think. So yeah, I think that's a wise decision, because, well, so I think I'm gonna do that. So src/c.zig, I believe. And yeah, I think that's the things that I'd like to ignore. Yep, pretty much. Okay, so now what we have, so we have a git ignore, we have a build.zig, and also I'd like to change some things about build.zig real quick, which is to fix some problems, which is if, well, let's see, if std, where did C imports come from? I created it, hold on. It's just a C header file. You basically tell it what you want. You basically put any C code here, it would translate it basically when you say translate C imports. So yeah. Here, if. Oh yeah, I need the built-in. I need to get built-in here. Const built-in import built-in. So if built-in.os.tag is equal to .windows, then and also if, I believe, optimize, how do I check if optimize is, well, here we go, hold on a second. I'm going to check my GitHub, my latest project on image viewer. Let's see, build.zig. There you go. So if xe.optimize equal release small, then we could do this basically. So honestly, we do not even need to check if it's Windows or not. It doesn't matter. Let's just do it for all platforms. So if xe.optimize equal release small, you have to do that. Is there anything other than that? No, that's pretty much the only thing, I think. So honestly, there's no need to check for Windows really. Although I'm doing this for Windows because when you don't do this on Windows and you go with the release small, it would break. It would not. It would error. So if exe.optimize equal release small, then exe.strip is equal to true. And just so everyone knows allows Windows to build for release small. So yeah. Okay, cool. And since this is one liner, guess we could do this, and let's put this guy here. And let's make sure everything is still working out. So yeah. Now, is there anything other thing? Is there anything else? I do not think. So that's build.zig, C imports, translate. I would like to maybe create a bash file. Bat file for Windows. But honestly, I do not right now have a way to test it. So I just let it slip for now. So yeah, that's pretty much it. Now let's just add this guy, and well, stage all, and context complete. Vulkan context, well, not complete, but well, Vulkan context, I guess, implemented. And commit, publish branch, publish to GitHub public repo, open on GitHub. And oh, I forgot the README, and also forgot the license, man. Well, easy peasy. Okay, so let's add a license. Gonna add MIT. Okay, let's add a license here. There you go. Other than that, we need a README. And for README, I wonder how much time is left for the prayer. Hold on a second. Yep, 6 minutes. Oh man. Okay. 6 minutes for morning prayer, so I should be quick a bit. Anyway, I'm gonna call this. I'm gonna give the link to a stream, at least. Being made in a live stream. Vulkan application made using the Zig programming language. Is there anything I should add? Oh, also build instructions. Okay. Well, I think like this. Translate C imports. How you would do that? Well, / translate C imports. Secondly, well, build. Zig build run. And yeah, pretty much. So add the license and the readme. What the? It's not exactly how I wanted, somehow. Weird. But anyway, who cares? Okay, so I'm just going to, for now, send this into the chat. Where is the chat? Okay, there you go. If there is any bug or you want to improve something or even add something, although if you want to add something, we're just going to use it to help or support developing the next in the next live stream. I think maybe we're gonna continue tomorrow, inshallah, maybe. But yeah, so what to do now? Yeah, I'm going to also post that into Discord. Also, join in Discord. I think you could find the link in the description to join Discord. I would notify you when the live stream is on. So, Vulkan application. Context done. Let's go. And there you go. I think that's... Also, maybe I would like to post it in Zig. So, Zig help or what? Projects. Okay. Where should I post it? I wonder. Maybe let's do this. Post it here. And then we could maybe post it here in projects. Oh man. So right now I need to go post. From scratch. Alright, so I need to go to my prayer right now. My morning prayer. So, see you later guys, and I think goodbye. Yeah, that was a pretty nice adventure. Goodbye everyone.